Good evening everyone, welcome to Gate Academy Global. So everyone be connected and just confirm me audio and video is both are perfect or not. Okay, everyone just confirm me audio and video both are perfect or not. Okay, so that we can continue the session. Okay, everything is perfect now. So last session I hope all of you have definitely watched. Okay, so from that part I am going to continue. Okay, so in last session we have discussed a two-port network, and today we will first finish the two-port network very soon. It will be finishes, and most important topic we will discuss transient. So today most of the time I will invest in the transient part. Okay, so today's session will be more important, and then after transient we will start our AC circuit. Okay, so now, so the main today goal is a transient part. Okay, we have to discuss in detail. So first we have to finish the two-port network. So in two-port network we have discussed Z parameter, okay, and we have discussed lots of things. Y parameter. I have provided you four method. If you can see one question, four method I have provided. Same concept you have to apply anywhere. Third, we have discussed H parameter. Okay, now, and already I have tell you, if any network contain dependent source, then you cannot say the network is a reciprocal or not. So you have to check by using any parameter. So if input side KVL, output side KVL, easily you can go with the Z parameter and you can check by Z parameter. If input side KCL, output side KCL, you can go with Y parameter. If you will get input side KVL, output side KCL, you can go with H parameter. So easily you will get this kind of equations. Okay, now, so don't say if network contain dependent source, so that is a non-reciprocal. No, you have to check. So this is a expertise, or you can say advantage of two-port network parameter. If the network is symmetrical or not, either by using this parameter you can say, otherwise directly if network is visible to you, suppose, so definitely you can directly see and you can say the network is symmetrical or asymmetrical. Now the next important parameter is ABCD parameter. Next important parameter is ABCD parameter. Today I am going to discuss ABCD parameter, combination of the parameter, okay, and some important concepts also. So now in ABCD parameter, we can also say this is nothing but a T parameter. Sometime we can say this is T parameter, okay, and this is T for the transmission parameter. Why transmission parameter? We will use this parameter in transmission line. So first, sir, what is exactly use of ABCD parameter? So here, sir, what is the use of Z parameter? Z parameter we use especially for T kind of network. You know very well T network. Okay, T network. Otherwise, you can also say this is nothing but T means star network. This is a star network. So if you have a T network or a star network, directly you can write Z parameter. But if you have here pi network, or you can say delta network, then directly you can write Y parameter. Sir, then what is the use of H parameter? So you know very well, this is a transistor easily represented by H parameter, because here four parameter you are getting. One is voltage gain, one is current gain, one is input impedance, one is output impedance. And in transistor, all these four parameters should be represented in terms of H11, H12, H21 and H2. So this is the advantage of H parameter. Sir, ABCD parameter. So now the important point is, you know very well, I know this, ABCD parameter. So this is your one network. Suppose this voltage is V1 plus minus, this current is I1, this is plus minus V2, always incoming current is I2. This is the important point. Where generally we use this transmission parameter when two networks are connected. This is the main use, where two networks are connected in this way, like this. Okay, so here for this network, this current is I1 and this voltage is V1. This voltage is V2 for second network. This current is I2. So now if you will connect these two networks, so here if you can see relation between these two currents, so just opposite of each other, opposite of each other. So in general, T parameter is used for cascade connection, not for single network. If single network is given, then T parameter don't have any use. This is the important point. If single T network, you can write Z parameter. If single pi network, you can write Y parameter. Transistor can be easily represented by H parameter. But if only single network is given, then there are no any need or no any use of ABCD parameter. That's why here ABCD parameter we represent one side. Okay, so this side if you will represent, or here if you will represent T parameter or ABCD parameter, so this will directly represent here. But here only V1 and V2 this is same, but I1 and I2 is opposite. That's why what we considered this opposite current, we can write minus I2. So this parameter is represented in terms of minus I2. This is the first important point. I2 direction is incoming. So we are going to write here. So input side KVL, input side KCL, already we have studied. So this is nothing but A V2 minus of BI2. Practically is AV2 plus BI2, but I2 you are considering opposite direction. The reason this thing is clear. Now I1 is equal to CV2 minus of DI2. Okay, so when you will write this matrix, this is very important point, because only here student can be trapped in GATE exam. So here V1 I1, you can write ABCD, and here you can write this is V2 and this value is minus I2. Okay, and now you know very well condition for symmetricity and condition for reciprocal. So what is the condition for here symmetricity? Two condition you know. One condition is sir A is equal to D, and second condition is del T is equal to 1. So already I tell you how you can remember. A is equal to D means this, and this is nothing but if you will compare with impedance Z11, this is Z22. So Z11 is equal to Z22, it means that is for symmetrical network. So A is equal to D is condition for the symmetrical. Don't do opposite here. This condition is for symmetrical and this condition will be for reciprocal. So this condition you should remember. Okay, now suppose for example you should know, I am going to take one basic circuit. Okay, generally you will use this kind of circuit in transmission line. Suppose here one impedance and suppose here one impedance. We have two impedances. Suppose generally transmission line you study here LC block, here LC block, and many number of LC block are connected in a cascade. Okay, so now the reason is clear here. So if you can write V2 and minus I2, so this will be equal to this V1 and this I1 equal to minus I2. So again you can write this ABCD parameter and you can put here. So again you will get a second term. If three number of network are connected in cascade, so again you can write. So if network are connected in cascade, then only ABCD parameter is used. For single network we cannot use. Okay, so suppose for example if this is the Z1 and if this is a Z2, so this is V1 plus minus this is I1 and this is V2, this is plus minus I2. I am not going to solve this. Easily you can solve this. Directly I am going to write this T parameter. Every student should directly know what is this T parameter. So what is this T parameter? What is this T parameter? First value is 1 plus Z1 by Z2. 1 plus Z1 by Z2. 1 plus a series by parallel. 1 plus Z2 by Z1. Okay. So this is very important thing. You are considering this is Z1 and this is Z2, or this is Z1 and this is Z2. But you remember by series parallel. So graphically you remember 1 plus Z2 by Z1. Okay. This is the first value. So what is the unit? 1 plus Z2 by Z1 unit is unitless, 1 unit is unitless. So this unit is unitless. Now the second value is only this one. So second value is only this one. Third value is 1 upon this Z1 and last value is 1. If possible you can remember this, and all the unit is unitless. This is unitless 1 plus Z2 by Z1. Okay. What this is unitless. What will be the unit of Z2n? What will be the unit of Z2n 1 upon Z1? This is the important point. So if I will ask you unit of this A unit is unitless. What is the B unit? V by I. So B unit is here impedance. So here this unit is unitless, this unit is impedance ohm, and this unit is mho or Siemens, and this is unitless. But generally nobody will talk unit in ABCD parameter. But here two parameter is unitless and one is impedance and one is admittance. Okay, so now this directly you should remember. Sometime you can directly use. So 1 plus Z2 by Z1, second parameter is this one, third is 1 upon Z1, and last one is 1. One thing you remember, this you can write only for reciprocal network. So if reverse question I am going to provide you, if you have a reciprocal Z parameter and if this value is 1, so directly you can represent this diagram. Already I tell you, electrical representation of Z network, electrical representation of Y network. So two Z network representation, one will having dependent source, one is T network. In Y parameter, one with dependent source and one with pi network. H parameter, only you have one electrical network. Here you don't have electrical representation. So here electrical representation is not possible. Electrical representation is practically not possible. But only in one situation you can write, if this last value means D is 1. If D is equal to 1 and the condition is reciprocal, and reciprocal network, then only this network can be drawn. So suppose for example, if one T parameter I am going to provide you, suppose for example this value is 2, this is 1, this is 1, and this is 1. Suppose for example, now I will ask you, sir, can we draw the electrical representation of this? Yes, you can draw electrical representation of this. You can see 2 into 2, 2 minus 1 is 1. So this is a reciprocal and this value is 1. So this kind of network you can draw. So what will be the network here? So here you can write one resistance, you can write in this way, and both the value is, this is 1 ohm and this is 1 ohm. Now the second question, if the same T network, suppose I am going to write, suppose this value is 2 1 1 1, then here 2 into 1, 2 minus 1, sorry, see you consider, now if this is 2, so you cannot draw here electrical representation. So here no circuit is possible, so you cannot draw. So mathematically only you can handle here. So by using mathematical equation you can handle, circuit you cannot draw. This is the important point. So what we can consider here, if examiner will provide you Z parameter, and if the Z parameter, you have two choices, either you can write down the equation or you can draw the circuit. In circuit you have again two conditions. If reciprocal, go with basic T network. If non-reciprocal, go with standard representation. Same for the Y parameter. Now H parameter, generally you can proceed with equation, and in T parameter generally you can proceed with equation. So one thing you remember, for H parameter and for ABCD parameter, always you can proceed with equation, and for Z parameter and Y parameter you have two choices, either you can go with circuit or you can proceed with equation. This is your choice. But one thing you should remember, if T network is given, if T parameter is given, always you can proceed with the equation, because anybody can solve question from the two port parameter, but time is the important point. I hope this thing is clear to all of you. Okay, so now the next question said, what is A dash, B dash, C dash, D dash parameter? So don't study A dash, B dash, C dash, D dash parameter. Okay, and don't write sir, T dash parameter is equal to T parameter inverse. No, this is wrong. Practically this is wrong. Okay, that's why I am saying do not study A dash, B dash, C dash, D dash parameter. Nobody will ask you this point. Okay, I hope this point is clear to all of you. Okay, now so here this answer directly at least you should know. 1 plus Z2 by Z1, Z2 1 upon Z1 and last value is 1. ABCD value directly at least you have to write. Okay, so now, all the 4 parameter exactly we have studied, and condition for symmetrical and reciprocal also is clear to all of you. Okay, now, so till now if anybody have any doubt, just ask me. Sir, digital marathon I am planning, signal marathon, after this network I am going to conduct signal marathon, and that will be a small duration. Okay, in 7-8 hours we will finish complete signal, and communication marathon also I am planning, and digital marathon always also I will try. Okay, so maybe next signal, then communication or digital, and then signal communication or digital. Okay, all these 4 subjects marathon I am going to conduct. Okay, so now the important thing I am going to discuss. Now one important thing I am going to discuss. Suppose here if I am going to provide you transformer, suppose this is a transformer, suppose for example, so you know very well transformer, suppose this voltage is V1, this voltage is V2, this current is I1 and this current is I2. This is incoming current, and suppose this ratio is, this is N1 ratio N2. Okay, transformer ratio first always you have to write. Here this voltage is V1, not this voltage, exactly this voltage. So here voltage you have to write V1, and here current you have to write this is I1. So this is V1, and here voltage is, this is V2, and here outgoing current is minus of I2. Okay, because transformer ratio is defined for outgoing current. So V1 by V2 is equal to minus of I2 by I1. You can write is equal to N1 by N2. This transformer ratio should be clear to you. Okay, now if I will ask you here, V1 is a function of V2, V1 is directly proportional to V2, and I1 is directly proportional to I2. So V1 is a function of V2 and I1 is a function of I2. So here Z and Y parameter, Z and Y parameter not exist. Already we have studied, not exist. So these 2 parameter not exist. Sir, ABCD parameter or T parameter will exist or not? What is the equation? V1 and this is I1. V1 is equal to AV2 minus B I2, and here CV2 minus of DI2. So V2 is not a function of I2. V2 is a function of I2? No. V2 and I2 are independent. Yes. T parameter exists. So here T parameter exists. Okay. So sometime you will get this kind of situation. Z parameter will not exist. Y parameter. So just you can change the way. So first you can see here, this is a dependent variable and this should be independent variable, V2 and I2. So if V2 is a function of I2, then T parameter will not exist. But here V2 is not a function of I2. So definitely T parameter will exist. Easily you can write T parameter. So V1 equation you can write in terms of I2, or can you write you can write in terms of V2. So here V1 is equal to, suppose N1, this ratio I am considering N ratio 1. Suppose, so V1 is equal to, this value is N ratio 1. So V1 is equal to N into V2, and from here I can write I1 is equal to minus 1 upon N into I2. So this you can also write V1 is equal to A V2. So A is equal to N and B is equal to 0. Now C is equal to, here V2 is not present, 0, and D is equal to, the important thing is this is minus I2, this is 1 upon N. So ABCD value you have find it out. I will ask you, sir, this is reciprocal? Yes, 100%. Why reciprocal? Only inductor are present. Coil means inductor. Transformer is only coil. Coil means inductor. Sir, this is symmetrical or not? Not symmetrical, because if this ratio is N ratio 1. So if N is equal to 1, then only symmetrical. If N is not equal to 1, not symmetrical. Okay, so from here you can see this is N, this is 0, this is 0, this is 1 by N. So here A is equal to D, no. A is equal to D for N is equal to 1. And A is not is equal to D for N is not is equal to 1. So if N is not is equal to 1, then this is asymmetrical. And here this is N into 1 by N, 1 minus 0. So here del of T is equal to 1, yes. It means this is reciprocal. So this was a very basic question. Okay, this was a very basic question. Okay, now, but one thing you should remember, okay, in two-port network, in concept, sometime in concept you can be trapped, only in concept. In calculation nobody will trap in two-port network, but in concept some student can be trapped. Okay, some student can be trapped. So now I am going to provide you two questions, okay, that you have to solve. Okay, this z parameter will exist or not, y parameter will exist or not, and t parameter will exist or not. And one more question here, z parameter will exist or not. Already we have discussed for z and y. So all these three parameter, all these four parameter, which parameter will exist and which parameter will not exist. Okay, so this is your homework. This R and R you can consider. Okay, this is a very basic question. Anybody can solve this. Anybody can solve this. Okay. Chaliye. Now come to the important point. This was very basic thing. Okay. Now if now the important thing I am going to discuss. Suppose for example, okay, very important thing I am going to discuss. Okay, first I am going to discuss interconnection of two-port network. Okay, first I am going to discuss connection of two-port network. Interconnection of how many number? Two number. So interconnection of two numbers of a two-port network, of a two-port network. Okay, so everybody know this thing very well. This was very basic thing. Just I am going to recall again. So two network can be connected in series, two network can be connected in parallel. Input side series, output side parallel, output side parallel, input side series. Both network can be connected in cascade. So total 5 conditions can be possible. So first condition I am saying input side series and output side series. So if we have two network, suppose for example, if we have a two network, okay, and if these two network are connected in series, so how we can say two network are connected in series? If this current and this current is same. So if just I am writing this like this, if input side series and output side series, so we can say this is series. We can say this is not only series, input side series and output side series. So in input port, same current is flowing in both the network, and in output port, same current in flowing in both the network. We can say this is series. So if two network are connected in series, then what you have to find out? You have to find out here this Z parameter. I can say this is ZA. This is network number A, and similarly you have to find here Z parameter. Okay, any parameter if examiner will ask you, you have to find out Z parameter. Then overall Z parameter will be is equal to first Z parameter plus second Z parameter. Okay, so ZA and ZB. First you have to find out and you have to add. Important point is input side series and output side series. How you can check the series? Already we have studied. But you have to check at input port series and output port series. If input port of both the network same current is flowing, and output port of network same current is flowing. So you know very well, if here this current is I, suppose this is I1, here this current will be I1, you know very well, then same current is flowing here. This is I1, here this current will be I1. So here same current is flowing. Similarly, if this current is I2, so here this current will be I2. So incoming current is I2, then outgoing current will be I2. Here this incoming current will be I2, and here this outgoing current will be I2. You can say this is V1 of complete network, and you can say this is V2 of complete network. Okay. So sometime this is also important. Okay, so according to me, this year examiner can ask question from this topic. So you have to at least remember. And what you have to do here? Okay, so for the first network you have to find out Z parameter. For the second network you have to find out the Z parameter. Okay, then overall Z parameter will be ZA plus ZB. Okay, this was the first connection. Now the second connection. In second connection, suppose input side parallel, I can say parallel connection. So input side connected in parallel and output side is also connected in parallel. Just I am saying how this will be visible. So here Y parameter you have to find out, and here also Y parameter you have to find out. So, okay, so Y you have to find out. This was your first network, this was your second network. This is the output port, this is the output port. So how you can say these two networks are connected in parallel? So both network voltage is same. So you can say this and this both are connected. This and this both are connected, and you can say this and this both are connected like this. So this will be V1, here this will be I1. Current is going to divided in this two. Similarly, this first port is same and this second port is connected. Here this voltage is V2 and here this current is I2. So input port and output port voltage is same. So here you can say this voltage is same here, this voltage is same here. So here voltage will be V1 and here voltage will be V1. Here this will be same voltage V2 and here this voltage will be same. So here this is parallel, here this is parallel. So we can say here this is a parallel and here this is a parallel. Okay, I know you everybody know this thing, but just I am going to recall. So parallel connection, some important point I will discuss. Okay, so wait for that. So parallel connection. So here total Y parameter first you can find out. So first network Y parameter plus second network Y parameter will be added. Examiner can ask you any parameter, but only first Y parameter you can calculate. Okay, so this thing you should remember. Now the number third. Okay, now directly I am going to write. So series and parallel you know very well. Now the number third. So here number third. Now in number third, input side series and output side parallel. If you will get this kind of network, means input side this connection and output side this connection. So can I write directly? Yes. So in this case, H parameter will be added. So total H parameter will be HA plus HB. So directly you can write. But you will not get this kind of question. Never you will get this kind of question. Only here question will be framed from here and here and cascade connection. Now number 4. If input side parallel and output side means input first port in port number 1, this is port number 2. So here Z parameter will be added. So ZA plus ZB. And you should know the relation between H and G. Suppose if you have calculated H parameter, so H inverse will be Z parameter. Okay, so no worry about G parameter. If examiner will ask you Z parameter, always you have to calculate H parameter. H inverse will be Z parameter. Okay, but do not worry, nobody will ask you this question. So this fourth thing you should remember. Now the number fifth. This is the important point. Number fifth, and this is the most important. Generally they target question from this fifth one. So here you can say this is series, yes. Parallel, yes. This is series, parallel, series. All combination is completed, yes sir. But if two network are connected in cascade, so number fifth one is cascade. And cascade definitely first block. So here you have to calculate T parameter of A, and this output, first output is connected to the input of the second. Here T parameter is connected like this. So here T parameter you have to calculate. This complete network V1, this is I1. Here this complete network V2, this is I2. Okay, here I can write V dash, this is plus minus, and this current is I dash. Anything you can write. So between current I have considered V dash and I dash. So how you can solve this kind of network? So if two network are connected in cascade, then both T parameter will be multiplied. So this T parameter you can easily calculate. This is TA dot TB. Both T parameter will be multiplied. This is important thing, multiplied. T parameter will be multiplied. One thing you remember, if this is matrix A, matrix B, so A dot B is not equal to B dot A. In matrix, you know very well. But just I am going to recall, if this is a matrix A dot, if this is a matrix B, is not is equal to matrix B dot matrix A. You remember this thing. This is very important point. Sometimes student will do wrong here. This multiplication is no, this multiplication this. So matrix A multiplied with matrix B. Okay, so this basic 5 thing you should remember. So examiner will ask question from here. This year, this is my feeling, examiner can ask question from either here or from T parameter. Now you will ask me, sir, reverse cascade. No, it is not possible. That's why only 5 parameter is required here. 6 parameter is not required. So A dash, B dash, C dash, D dash, there are no any use of this parameter. No use, zero use. That's why generally some teacher and some student will not study T dash parameter. Okay, because that is practically not required. So this 5 parameter is required, and generally we say, sir, Z parameter is also not an important part. Okay, so here interconnection of network, this connection generally examiner will not target. These 3 connections can be targeted. Okay, now I am going to ask you one important concept and one important question. Okay, now one important thing I am going to ask you, and I hope this kind of question from last many year they are targeting this kind of question. Okay, now I hope this thing is clear to all of you. Now one basic question I am going to consider here. Okay, now one basic question, very basic question. Okay, and this is concept based question. Okay, and this question is concept based question. So now suppose for example one network I have provided you. This is very basic network. One network I have provided you. Okay, this is V1. This current is I1. This resistor, just I am going to assume this is 1 ohm. This is 2 ohm and this is 3 ohm. Okay, this is V2 and this current is I2. Okay, now my question is find out this Z parameter. So can I write directly? Yes, we can write directly Z parameter. Sir, what is this Z parameter? So what will be Z parameter? Sir, first value 1 plus 3, this is 4. Second value is 3. Third value is 3 and fourth value is 3 plus 2, 5 ohm. Can I write? Yes, sir, we can write. This is Z parameter. Okay, all the unit is ohm. I can write here common unit ohm. Okay, easily you can write. I will ask you, sir, this is reciprocal or symmetrical? Z11 is not equal to Z22. Asymmetrical, but reciprocal? Yes, only resistor reciprocal. So this is reciprocal but asymmetrical. So here can I write this is reciprocal and asymmetrical. Okay, now this is very basic question, but wait for the concept, and this from this concept definitely this year question will be asked. If examiner will not target this one, definitely examiner will ask question from this concept. Wait, I am going to discuss, but first we have to find out some parameter. Then what is the, sir, Y parameter? What is Y parameter? So Y parameter will be yes, you can write Z inverse directly. Can I write? Yes, sir, Z inverse. So Z inverse will be adjoint of Z divided by determinant of Z. Determinant 5 into 4, 20 minus 9. 20 minus 9 is 11. So this first value is 5 by 11. Second value is minus 3 by 11. This is minus 3 by 11 and this is 4 by 11. And all the unit is either Maho, or you can write ohm inverse, or you can write Siemens. Anything you can use. Okay, anything you can use. So Y parameter you have also find it out. Okay, good. Sir, what is the H parameter and what is ABCD parameter? Okay, what is H parameter and what is here T parameter? So this 4 parameter just I am going to ask you. Okay, this 4 parameter. So now the third parameter, H parameter. So H parameter, how you can find out? You have to solve the equation. Yes, sir. So Z parameter equation you can open. V1 is equal to, and in another way you can see here, if you remember how we can write H parameter in equation in terms of Z and Y, then directly you can write. But if you don't know, then you can find out V1 is equal to 4I1 plus 3I2, and here V2 is equal to 3I1 plus 5I2. Can I write 4335? And what is H11? What is H11? H11 is nothing but, I can write the H parameter equation once, V1, and this is nothing but I2. Input side KVL and output side KCL. So this is H11 I1 plus H12 V2. This is H21 I1 plus H22 V2. You can write now from here. What is H11? H11 is nothing but V1 by I1, V2 is equal to 0, and V2 is equal to 0 second, H22. So H22 is equal to I2 by I1, sorry, I2 by V2. H22 is nothing but I2 by V2. I2 by V2 when H22, no, H21. H21 I am going to find out I2 by I1. I2 by I1. I2 by I1. So what is I2 by I1? H21 when V2 is equal to 0. Okay, so V2 is equal to 0, two value you have to find out. H11 and H21. So you can do here V2 is equal to 0. So if V2 is equal to 0, from here you will get, if V2 is equal to 0, 3I1 is equal to 5 pi 2. 3I1 is equal to 5 pi 2. Okay. So here what is here to find out? I2 by I1. So I2 by I1 is equal to 3 by 5. I2 by I1 is equal to 3 by 5. So this I2 by I1, you are getting 3 by 5. And what is the unit? Unitless. Sir, what is V1 by I1? V1 by I1. So from here you can find out I2 value you can replace. I2 value is here 3 by 5 pi 2. So this is 3 by 5 pi 2. So here, sorry, I2 value is 3 by 5 I1. This is 3 by 5 I1. So 3 into 3. So here you can write V1 is equal to 4 plus 9 by 5. 4 plus 9 by 5. Can I write? 4 plus 3 into 3, 9 by 5 I1. So here this is 20 plus 9, 29 by 5. So V1 is equal to 29 by 5 I1. So here V1 by I1, 29 by 5. 29 by 5. Can I write? And what is unit? This unit is ohm. This is unitless. Okay, so two value we have find it out. Here I am going to write H parameter. So what is the H parameter? So first value H11, 29 by 5. This is ohm. What is the H21? 3 by 5, and this is unitless. Now remaining two value also you have to find out. So now the third value. Now the third value is we have to find out H21. H21. So what is H21? H21 we have find it out. H12. What is H12? H12 is, you know, voltage gain, reverse voltage gain. This is V1 by V2. So this is V1 by V2 when I1 is equal to 0. When I1 is equal to 0, and H22. So what is H22? H22 is nothing but I2 by V2. This is admittance when I1 is equal to 0. Okay, so from here you can do I1 is equal to 0. So if I1 is equal to 0, V1 by V2 will be 3 by 5. If you will divide this I1 0, I1 0, and if you will divide V1 by V2, I2 cancel, 3 by 5. So here you are getting 3 by 5. Here you are getting 3 by 5. So H12 we are getting here 3 by 5. Okay. So this is 3 by 5. I think there are some mistakes. Okay. Here actually we did wrong. Na? Here this will be negative. 3I1 is equal to 5 pi 2. So this is 3I1. This will be minus. This will be negative. Here we did wrong. This will be negative. This will be negative. Okay, we did wrong here. So I2 by I1 will be minus 3 by 5. This is minus 3 by 5. So we did wrong. So this will be minus 3 by 5. Corrected. Sorry. This value is minus 3 by 5. Here this value is minus 3 by 5. Here this value is minus 3 by 5. Yes, H2 and I have corrected. Okay, now that is minus 3 by 5. Now again I am going to recheck this. So here V1 is 4I1 plus 3I2. So I2 is minus 3 by 5 I1. So this is minus 3 by 5. So this is minus 9. So this is minus 9 by 5 I1. So 20 minus 9, 11 by 5. So again you have to correct this. 11 by 5 I1. Correct this. Okay, now. So 11 by 5 I1. Okay, so this is 11 by 5. Okay, now this is correct. So this value is 3 by 5. Yes. How I can find out our answer was wrong? How I can think? Because already we have checked here the network is reciprocal. So if network is reciprocal, so H21, this is H12 should be equal to minus of H21. But if both are same, then it cannot be reciprocal. That's why I find it out there are something, we did some mistakes here. Okay, so now last point H22. So here I1 is 0, and I2 by V2, this I1 is 0. So V2 is equal to 5 by 2. So I2 by V2 is equal to 1 by 5. So this value you are getting 1 by 5. 1 by 5 unit is a mho. Okay, so this is 1 by 5. This is 1 by 5 and unit is mho. Okay, so all these three parameter, T parameter also we can find out. Now my question, what is my question here? The important point is this. Now my next question. Now my next question is, if I am going to modify this circuit, one extra resistance is connected here. So if one extra resistance is connected here, suppose one extra ohm, this is 1 ohm, this is 1 ohm, this is 2 ohm and this is 3 ohm. Okay, so just one extra ohm I have connected here, and now this is V1, this current is I1, now this is V2 and this current is I2, this current is I2. Okay, so here which parameter will be modified in Z, which parameter will be modified in Y, which parameter will be modified in H? This is my question. Okay, so now our calculation is correct. Anybody can now everybody tell me our calculation is correct. No calculation you can check please. Okay, so now the question is, examiner many times this kind of question has been asked, but till now they have asked very easier question. Till now they have asked very easier question. So if I will provide you, so directly Z parameter you can write. Yes sir, Z parameter easily we can write 1 plus 1, this is 2 plus 3, this is 5. Sir, this is 3, this is 3, this is 3 plus 2, 5. Can I write? Yes. So you can see here which parameter is modified. So here you can see, sir, this is same. Yes, sir, this is same, this is same, this is only modified. So Z11 will be modified. So here only what you can say, sir, Z11 is modified. So in Z parameter, so if you will add one resistance, extra resistance in series, then Z11 will modified. Clear my question? Now, sir, in Y parameter, which will be modified? So can you find out here Y parameter? Yes. So what is the Y parameter? Y parameter is here. This determinant is 5 into 5, 25 minus 9. So 25 minus 9 is 16. So this is first value is 5 by 16. Second value is minus 3 by 16. This is minus 3 by 16. This is minus 3 by 16 and this is 5 by 16. Can I write? Determinant is 5 into 5, 25 minus 9, that is 16. Which value is going to be modified from the Y parameter? Sir, this first value is modified. Yes. Sir, second value is modified. Yes. Sir, third value is modified. Yes. Sir, this fourth value is modified. Yes. So here all the value is modified. So this is the important point. So examiner will not ask you the question from value. They will ask you by the block. They will provide you here one block and they will provide you any parameter. And here suppose one series resistance if examiner will connect. And now examiner will ask you which parameter can be modified. Which parameter can be modified? So now you have to find out. So in Y parameter, all parameter. So in Y, all parameter modified. All parameter modified. This is the important point. All parameter is modified. So in Z, only Z11 modified. But in Y, all parameter will be modified. Why in Y all parameter will be modified? Actually, your previous network was this one. Okay, now, and this voltage I can say, suppose this voltage is here V dash. So here V dash and V1 both are same. No. So here what is going to be exactly happen? This voltage is going to be modified. Current is same in both. Here this current is I1 same. Here this current was I2. Both voltage was same. Here in the both the case current was same. And so if current was same and one extra resistance are connected in series, then only Z11 is going to be modified. But in Y parameter, this voltage is going to be modified. So this V dash and V1 both will be changed. So if voltage is going to be changed, so every parameter can be modified. How you can write? So in Y parameter, I1 is equal to Y11 V1 plus Y12 V2. And here I2 is equal to Y21 V1 plus y2 to v2. So here v1 is going to be modified. So here in this equation, if this value is modified, all the parameter will be changed. If here this value is modified, all the parameter will be modified. So first you have to think, if resistance are connected in series, so how you can learn? So if in input port, you can say this is a input port. So if input port, anything are connected in series, anything are connected in series. So what you can think here, sir, in Z parameter, input side was series connection, input side was series connection, and if any element are connected in series, if any elements are connected in series, then only one parameter in Z, only one parameter is going to be modified. If one resistance are connected at output side in series, then only one parameter will be modified, which Z22. One parameter will be modified, Z22. Now my second question, I hope this thing is clear to all of you. Now my second question, if I will connect here one parallel resistance, then which parameter will be modified? So in Y only one parameter will be modified. In Y only one parameter will be modified, but in Z all the parameter can be modified. This is the important point. This is the important point. So Z parameter supports series connection, input port and output port, and Y parameter support parallel connection at input side and at output side. So if you will connect here in series, so in Z parameter only one parameter will be modified. If you will connect here in series, in Z only one parameter will be modified. But if you will connect here parallel, so in Y parameter only one parameter will be modified. If here you will connect in Y only one parameter will be modified. This is the important point. So here what examiner can ask you the question, here one series resistance they will connect and they will ask you which parameter is going to be modified. So you can say only input side series in Z and one extra resistance you are connecting in series. It means you can say only Z parameter is going to be modified, only one parameter, that is Z11. But in Y all the parameter can be modified. Now my question, sir, in H parameter, which can be modified? This is the important point. Sir, in H parameter, which can be modified? Already you answer for H parameter. So anybody can tell me, sir, in H parameter. So anybody can tell me in H parameter, which parameter can be modified? Can you think? Can you think? Which parameter can be modified? So can I write equation again? Yes. So now easily you can find out from here. Again I am going to find out from here. Okay, now. So here first you can write down the equation. So V1 is equal to Z 5 pi 1 plus 3I2, and here V2 is equal to, this is 3I1 plus 5 pi 2. So first equation, H11 V1 by I1 V2 0. You can do V2 0. So if this V2 is 0, so from here you will get 3I1 is equal to minus 5 pi 2. So from here you will get first I2 by I1 is equal to minus 3 by 5. So H21 you are getting same. H21, this is H21, this is same. So this value is same. Okay, now what is, sir, V1 by I1? If V2 is 0, so from here this I2 value you can replace. I2 is equal to minus 3 by 5 pi 1. Can I write? This I2 is equal to minus 3 by 5 pi 1. So this is 5 minus 9 by 5. So 25 minus 9, 16 by 5. So V1 by I1 is equal to 16 by 5. So this value is going to be modified. Yes, this is going to be modified. So this is going to be modified 16 by 5. Okay, so which value is modified? One value is modified, that is H11. Now come to the point here. So 3 by 5 and 1 by 5, which value is going to be modified? Sir, 3 by 5 and 1 by 5, which value is going to be modified? Now you can see here. So what is H12 and what is here H22? So what is H12? V1 by V2 I1 0. So you can put this value 0. So from here V1 by V2 is 3 by 5. So this value is again same, 3 by 5. So this value is again same. 3 by 5. Okay. Now the last value. Sir, what is I2 by V2? So from here I2 by V2 is nothing but 1 by 5. So this I2 by V2 is nothing but 1 by 5. This value is 1 by 5. So again this value is same. This value is same. This is very important point. This is very important point. So what I can say here, sir, if you will connect series resistance at input side, then in H parameter only H11 will modified. So here only H11 will modified. This is very important thing. Only H11 will modified. In the circuit given, can we calculate Z parameter as a cascade? No, Z parameter cascade you cannot. If you are considering two network are in cascade, then only T parameter will be multiplied. No, Z parameter you cannot multiply. Remember, if you are assuming, sir, this network and this network are connected in cascade, then you have to find out this T parameter, you have to find out this T parameter, and T parameter multiplied, you will get T parameter. Then by using T parameter, another parameter you can find out. That's why in general in GATE exam, we don't go with this interconnection of network, because this process is generally time consuming. If direct question, examiner will ask you from that part, direct question, if two networks are connected in cascade and they are providing T parameter, and they are asking T parameter, then we can go with that. Otherwise generally by KCL, KVL equation, in another way, we can replace star to delta, delta to star, and we can simplify the network and directly you can find out the parameter. So how you can handle this network? So suppose if you want to find out suppose this Y parameter directly, so what you can do, this is star you can convert into delta, and for delta or pi network directly you can write down the Y parameter. So this kind of process we can apply here. Okay, so now here one concept I want to tell you. Okay, one concept I want to tell you. I hope this thing is clear to all of you now. So in GATE exam, what is my feeling? This question will be asked this year in GATE exam, but examiner will ask you in theoretical manner. Okay, how? So here this is a one network. This is a one network. All parameter you can find out. Okay, like this. So now the important thing is here. Suppose for example, if here this is here, if I will connect one series extra, this series resistance, then which parameter can be modified? So you can see input port series. So if I am going to write, you can see here this is input port and this is output port. This is output port. Okay, input port and output port. First parameter Z. So input port is series, output port is series. Now here Y parameter, input port parallel, output port parallel. In H parameter, input port series, output port parallel, and in G parameter, input port parallel and output port series. Okay, but in general examiner will target here Z, Y and H parameter. They will not target ABCD or they will not target G parameter. Now you can see if this extra resistance, this is the extra element. Okay, if extra element connected in series, suppose for example at input port. So input port, if extra element connected in series and series, then only one parameter will be modified, H11 and Z11. I hope this thing is clear now. Now if this extra resistance are connected here in series, output port in series, so you can see where output port in series, here and here. So here and here only one parameter will be modified, but here and here all the parameter can be modified. Are you getting this point? So but if I am going to connect here one resistance in parallel, then what will happen? So here this was series, but you are connecting parallel. So for Z all the parameter, and here this is parallel, this is parallel. So Y only one parameter. So in Y only one parameter can be changed. Here this is series, but this is parallel. So all the parameter can be modified. Here this is parallel, here this is parallel, only one parameter will be modified. So just you can match this. Now suppose if here I am going to connect one resistance here in parallel. So if this is series and this is parallel, so for Z all the parameter can be modified. If this is parallel, this is parallel, so for Y only one parameter will be modified. Here this is parallel, here this is parallel, only one parameter will be modified for H, and for G all the parameter can be modified. So like this you can apply the concepts. I hope this thing is clear. Just we have proved this. Okay, for T parameter we can consider, but examiner will not target T parameter here. Just you can leave. Okay, if examiner will provide a T parameter, so just cascade you can multiply. you can multiply. Okay, so like this you can handle the question, like this you can handle the question. Okay, suppose if examiner will ask you here, sir, t parameter. So t parameter, this t parameter you can find it out. This t parameter you can directly write. You can assume here one resistance, this is 0, and already we can write 1 plus z2 by z1, second value is z2, then 1 upon z1, then 1. So this 2 t parameter you can multiply, t matrix you can multiply. Okay, but first one is this, second one is this. So this basic concept should be remembered to you. Already this question has been asked previous year GATE exam. This question from this concept already they have asked. What they have provided? They have provided for one network we have a z parameter. So what question exactly they have asked in previous year? They have provided one z parameter. Okay, now what examiner have provided? This kind of question they have asked. This was a network and this z parameter is given. This z parameter is z11, z12, z21 and z22 like this. Okay, and here then they have connected one z in like this. Okay, now what is the z parameter of complete network? So directly you can write, sir, z parameter input port was series and one extra resistors are connected in series. So what is this complete z parameter? So directly you can write this z11 plus zin, z11 plus zin, and remaining parameter will be same. Remaining parameter will be same like this. This is the answer. So already this question has been asked. But if y parameter they will ask you, suppose if this is y11, y12, y21 and y22, then all the y parameter can be modified. Then all the y parameter can be modified. I hope this thing is clear to all of you. Okay, I hope now this thing is clear to all of you. Okay, so this can save your time. So in two-port network, the important thing is how much time you can save. Anybody can handle the question from two-port network. Okay, so I am going to recall all the two-port network. Okay, so once just tell me everything is crystal clear here or any doubt in two-port network? Okay, remaining every portion are very easier part. Okay, only you have to do calculation here. Only you have to do calculation here. Okay, so now according to me, you can handle the question from two-port network. Okay, now, so just I am going to recall once. Just I am going to do recall once in two-port network. Sometime you will get a load resistance also in the network. That question will be very easy. If RL is given, so here if this current is I2 and this voltage is V2, so directly you will get one relation between V2 and I2. So V2 is equal to minus I2 RL. So if you will get any resistance in the load, so that kind of question will be very easy. So first equation you can write this, one relation in V2 and I2. So already if you have find out one relation, so any equation easily you can handle. Okay, so once you can keep in your mind, if load resistance is provided by the examiner, that kind of question will be very easier. That kind of question will be very easier. Okay, that will be very easier question. Now just I am going to recall all the part. So in Z parameter, lattice network should be clear to you. How you can write directly lattice network? Already I tell you ZA plus ZB by 2, ZA minus ZB by 2. But which one is ZD? Diagonal. ZB is your horizontal, or you can say series. Okay. Now the second 4 method I have provided you for one question. So that 4 methods should be clear to you. Okay. Any parameter you can handle from that. Z to Y conversion, Y to Z conversion. This is 2 cross 2 inverse matrix. Easily we can handle. Now next important point, you remember in Z, in Y, in H parameter, in ABCD, which you are considering input side series, output side parallel, like this. This thing you should remember. Now interconnection of network. Generally you should avoid interconnection of network. Direct formula. If examiner are asking the Z parameter and network are answering, then you can go with. So according to me, direct question they will ask from the interconnection of the network. Okay, but generally they will target interconnection of network question from T parameter. Now transformer, already I have discussed the transformer is very easier part. Okay, reflected impedance concept should be also clear to you. Okay, just I am telling you. Okay, okay, later I will tell you. Okay, just first I will finish the basic part here, and then next category of question they will ask you. Okay, they will provide this kind of box, and any kind of extra circuit here they can connect, here they can connect, here they can connect, here they can connect, and they can ask you what is the new parameter. So if all the 4 options they will provide you, so from that 4 options easily you can take the answer. You have to save the time, otherwise it will be time consuming. Remember my word, if 2 network are connected in cascade, in series, in parallel, that kind of network will consume more time. So in that portion you have to save the time. You have to save the time. Now the important point, okay, how you can handle the transformer question. Suppose here we have one transformer. Suppose we have one transformer. Transformer ratio you know very well. Now suppose for example this voltage is V1, this current is I1, and this voltage is V2, and this current is I2. Okay, now suppose for example here one resistance I have connected, this resistance is RL. Now so if you want to calculate impedance here, so I can say this is Rin. What is the relation between Rin and RL? So I hope everybody know this thing, but just I am telling you how you can write. And this ratio is if N1 ratio N2, and this I am going to assume N ratio 1. Okay, so transformer ratio we know very well. Transformer ratio we know very well. What is transformer ratio? V1 by V2 is equal to, here I can write N by 1, and second minus of I2 by I1 is equal to N by 1. Can I write? Okay, now if you will multiply this two equation, so V1 into V1 by I1, can I write V1 by I1 into minus of I2 by V2, is equal to N by 1 into N by 1, N square. And V1 by I1, can I write V1 by I1 is nothing but R in. So this is nothing but R in, and minus I2 by V2. So if this current is minus I2, so V2 by minus I2 is nothing but RL. So this you can write 1 by RL. So can I write R in is equal to N square into RL. So this is called reflected impedance. This formula everybody know. I think everybody know this formula. So if examiner will ask you question from transformer, so easily you can handle like this. So here just again I am going to draw. If you have one transformer, suppose for example, and suppose here if this is 5 ohm, so what is here input impedance Rin. So this complete transformer can be represented by one Rin. So what is the Rin? Here if the ratio is N ratio 1, and this is suppose 3 ratio 1. What is the Rin? So you know very well Rin by RL. So Rin by RL is equal to N1 by N2 whole square. So you can also write Rin by RL is equal to N2 by N1 whole square. You can write in this way. Sorry, N1 by N2 whole square. This is N1 by N2 whole square. Clear this thing? So from here Rn is equal to, this is 3 square into this resistance is 5. So 9 into 5, 45 ohm. So what is Rin here? Rin is equal to 45 ohm. Okay, so sometime, but this kind of question will be important for general electrical students. And you know very well, already you have studied electrical machine, and every time you use these things. Okay, so for electronics student, only you should remember this thing. So if a transformer is given, so just you can replace the transformer by resistance, Okay, so this transformer, if transformer load resistance is given, so this transformer you can remove, and this complete transformer will be replaced by one resistance, and this resistance is a 45 ohm. Okay, so easily you can handle this kind of question. Okay, now Okay, so I am not going with this. So next topic, can we start? Can we start the next topic? I hope two port network easily you can handle. Okay, I hope two port network easily you can handle. Okay, electrical students, this part is important, especially for the electrical. Electronics is not much important. So only you should know these things. And for electrical and IN student, now machine subjects are in your syllabus. So you should be expert in this part. Okay. So so can we start next topic? So can we start our next topic? Okay. The most important topic is transient. So shall I start transients now? Okay. Be ready for the transient. Okay. And now you can share the video in different groups. If students are interested in transient, at least they can attend the session. Okay, this is exactly a revision session. So I am not going in deep in many points. Just I am going to recall you all the points, and I am telling where you can be wrong in the GATE exam. Okay, so two port network was easier topic. Some important concept only I tell you here. Now the next topic I am going to start transients. Transients. Next topic I am going to start transients. Okay, next topic I am going to start transients. Okay, so everyone ready for the transients? Okay, now so in transients, exactly, first what basic you should know, what basic you should know. Okay, I am not going in all the part because this is very big topic. Okay, so what basic is required for the transients, what equation is required. So first thing in the transient, sir, inductor and capacitor. So transient behavior will be exist for inductor and capacitor element. Otherwise means you can say energy storing element is present, then only transient behavior will be happen. Okay, transient behavior will be happen. Sir, load resistance part in the Z port network, load resistance part in the Z para network have doubt. Tell me again what is exactly doubt, I will recall. Okay, tell me your doubt, and then after 2-3 minutes we will start transient. Okay, post your doubt. Okay, I am waiting. Okay, and everyone ready for the transient? If you have any doubt in till now in network theorems, in two port network and in basic concept of network, just tell me. Sir, in last Z parameter network, in last Z parameter network, in Z parameter, sir, when you added load resistance, yeah, if load resistance will be given, so examiner will not target a parameter. Examiner will in generally, suppose for example we have a network and this Z parameter is given. Suppose for example, suppose this is Z11, Z12, Z21 and Z22. Okay, and if here load resistance is connected, okay, suppose this is RL. Okay, suppose this thing is given, suppose this is V2, this current is I2, so this current will be minus of I2. Here suppose this is V1 and here this is I1. So when load resistance is connected, examiners are interested in input impedance. In that kind of question, examiner will ask you Zin. Generally, examiners are interested in Zin. So Zin will be unconditional Z parameter V1 by I1 without doing anything, 0. Examiner will ask you this thing without doing anything, 0. Suppose for example, I am going to assume if this is a symmetrical network, sorry, this is a reciprocal network, suppose for example, so you can draw a T network if this is a not a symmetrical network. Okay, so just you can draw the different network in which in series side you have one dependent source and in output side you have one dependent, otherwise you can write down the equation. So here you can go with equation V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 V2, Z22 I2. So you can write this equation, examiner will provide you this 4 values. So now you can write one equation here. So what is V2 is equal to, can I write minus of I2 into RL. So V2 and I2 one relation you have find it out. So in V2 and I2 one relation you have find it out. Already in V2 and I2, so you can replace the V2 by I2 or I2 by V2. So you can replace here I2 by V2. So if I am going to replace this I2, so I2 is equal to minus 1 upon RL into V2. Can I write? So you can replace this I2. So from this equation, V2 is equal to Z21 I1 and this is Z22, this is plus Z22. I2 you can replace minus 1 upon RL. Minus 1 upon RL into V2. And this V2 you can consider common. So this is V2 1 plus this is V2 1 and this is plus Z22 by RL is equal to Z21 I1. So from here V2 and I1 one relation you have find it out, V2 and I1. Okay, so here what you can do, V2 and I1, suppose if you want to find out V1 by I1, then what you can do, V1 by I1, so this I2 should be also replaced by V2. This I2 should be replaced by the V2. Okay. Otherwise, this I2 should be replaced by V2 and V2 value you can put in terms of I1 from here. If value will be provided, easily you can put. So if RL is given, examiner will target V1 by I1. So if this value is given, this is given, this is given, this is given. Okay. So this I2 you can replace this I2 by V2 and you will get here I1 in terms of V2, or this V2 should be replaced by I2. You will get one relation between I2 I1 and this I2 should be replaced by I1. So here you will get equation in terms of V1 and I1. So V1 by I1 easily you can find it out. So what you have to do, if load resistance is given, first you can write down this equation. So you will get one relation between I2 and V2. Then which parameter is given, you can write down both the equation. Easily you can handle within 20-30 seconds. Easily you can handle. But generally if this kind of question will be given by examiner, they will target V1 by I1. So easily you can find out from here. V2 again you can replace by minus I2 RL. So this value V2 is minus I2 RL and this value is 1 plus, here I can write this is nothing but RL plus Z22 divided by RL is equal to Z21 I1. Can I write this RL and this RL will cancel out. So I2 and I1 one relation you have find it out. So I2 value in terms of I1 you can find out. So this is I2 is equal to, this value is minus Z21 divided by RL plus Z22 into I1. So this I2 value you can put here. So if you will put here I2 value, so from here what you will get? You will get V1 is equal to, this is Z11 I1. So this is Z11 I1 and second value this is negative. So I can write minus of Z12 Z21 divided by RL plus Z22 into I1. So I1 you can consider common. So from here V1 by I1 is equal to Z in. V1 by I1 is equal to Z in. This is nothing but Z11 minus of Z12 Z21 divided by RL plus Z2. Calculation you can check. Just I am telling, this is derivation. So in GATE exam you will get the value. So they will provide you this value. So once you remember, if RL is given, so first you can write down one equation in terms of V2 and I2. Which parameter they have provided, write down the equation. Easily you can handle this question. Within 30 seconds, anything you can solve. But generally examiner will target In this category of question, Zn unconditional Z parameter V1 by I1 without doing anything, 0. Okay, I hope this thing is clear. Okay, now I hope now this thing is clear to all of you. Okay, so now I am going to start transients part. Okay, and this will be very beneficial and very important for you. Okay, I hope this thing is clear to all of you. Okay, so now we are going to start transients. Now we are going to start transients. So there are so many basic concepts you should know in the transients. Okay, just I am going to discuss that part. So we know very well transient when inductor are present L and when capacitor are present or when both are present, then only transient will be possible. Then only transient will be possible. So here we are going to discuss DC transient. So our source will be DC. So this is especially DC transients. This is DC. So our source will be here DC source. Sometime we can consider impulse function as a source sometime. Okay, but here AC, our supply is not a AC. So this is the different thing. This is the different thing. Our supply is not AC. Here our supply is DC. Our supply is DC. So exactly this topic name is DC transient. Now you will ask me, sir, if AC we will apply, then what will happen? If we will apply AC, then generally examiner are interested in a steady state value. So our next topic will be sinusoidal steady state analysis. This is called SSSA or S3A. This is called sinusoidal steady state analysis. So when our supply is AC, so examiner will not ask you the transient part. Sometime transient free condition they can ask you. Okay, so I hope you have studied some condition for transient free response and 2-3 basic standard formulas you should remember. So I am not going to discuss that part here. I hope you remember that formula. So sometime for AC supply, when supply is AC, examiner are interested in transient free response. So for AC supply, examiner are interested in a transient free response. Transient free response. Okay, so for RL circuit or RC circuit, so for RL circuit and RC circuit, examiner are interested in transient free response. Okay, so this condition you should remember, but nobody will ask you question from here. You can leave this topic also. But in RLC circuit, transient free condition is not possible. So here for RLC, transient free condition not possible. Transient free condition is not possible. Condition is not possible. For AC supply, not possible. So this is a second order circuit, and the second order circuit generally most of the thing you can handle by the control system. Peak overshoot they can ask you, so they can provide you RLC circuit. Okay, we will discuss, don't worry. Okay, so they will provide you RL circuit and they can ask you many things. Practically this part is in resonance. So generally we will handle here when AC supply and RLC circuit. So we will discuss here resonance. So I hope this thing is clear to you. So if your supply is AC, so either it can be RL circuit, RC circuit or RLC circuit. RL circuit and RC circuit, examiner are interested in transient free response, and in RLC circuit, examiner are interested in resonance. Examiner are interested in resonance because here transient free response is not possible. But for DC, transient free response is not possible. So once, this is the important thing, if your supply DC, so here transient free response is not possible. Transient free response is not possible. This is the important thing. That's why we studied transient part in DC supply. Clear this point? So why you study only DC transient? Why you not study AC transient? This is the reason. Because in DC supply, transient free condition cannot be possible. So one example just I am providing you. Suppose you have one fan, and suppose inside the fan we have RL circuit. Suppose RL circuit. When you are going to press the switch, fan will reach to final value slowly if supply is DC. But if supply is AC, it is possible fan can be reached to final value in same time. So two things you can see when you are pressing the switch for the bulb. Standard only resistive circuit, it will glow instantaneously. It will glow, okay, instantaneously, okay. But when suppose you have a fan will not reach to final value instant, okay. So fan will not going to reach final value at same time. The reason is this: what is the supply, what is the circuit inside the network. There are so many parameters. So right now you should remember only one thing. For AC supply, generally in this subject, what we believe, RL circuit and RC circuit, we are interested in transient phase response. And for DC supply, for RL circuit and RC circuit, we have to calculate a transient value. And for RLC also we have to calculate transient value. And if AC supply, for RLC circuit, we are interested in here resonance. This thing we have to study. So here the important point is you have to more concentrate on L and C. So behavior of L, behavior of C should be very much clear to you. Behavior of inductor and behavior of capacitor should be very much clear to you. So some important thing I am going to tell you. So now first I am going to consider here inductor. Okay, very important point I am going to tell you. Suppose I am going to discuss here inductor first. So this is your inductor, this is your inductor. One thing you should remember, in real life inductor cannot be pure. So inductor in real world cannot be pure. This is a pure inductor, but actual inductor is a, we can say that is nothing but coil. This is nothing but coil, and coil is practically one series resistance having what inductor like this. This is the actual coil. So nobody can generate, or you can say design, pure inductor. Okay, this thing you should remember. So sometime what examiner can provide, inductance value with some internal resistance, and that you can connect in series, and generally sometime you can call this is a coil. But here right now we are going to discussing your standard, or you can say pure coil. So suppose this is a pure inductor and this inductance value is L. So now if you are, suppose voltage across this inductor, we are going to assume VL of T, and suppose current across this inductor is IL of T, suppose for example. And what your assumption, our assumption was inductor is a passive element. So current and voltage direction is very important. So in inductor what you will write, this is the important point, always current direction will be enter from positive terminal. It can be negative, but what your assumption, always current should enter from the positive terminal. This is the important thing. Now Ohm's law should be clear to you. For the inductor we know very well what is the inductor voltage. VLT is nothing but LDI by dt, LDI by dt. Okay, but this formula is valid when this current is incoming from the positive terminal. If you will change the direction, then this formula will be modified. This is very important point. When you are going to draw, or if inductor is given, and if you know the voltage direction, current direction always you have to assume from the positive. From the positive current, from the positive terminal, current will be incoming across the inductor. It can, answer can be negative, but your assumption should be this, because this formula is derived for this condition. Now the second, what is a inductor current? You should know this thing. ILT is nothing but 1 by L integration of minus infinite to t. This is voltage across inductor dt. So this formula is derived for this condition, and this you can also divide into two parts. First we can write IL0 and plus 1 upon L integration from 0 to t. This is VLT dt. Okay, this thing you should know. Now the next formula, what is the energy across inductor? ELT half L ILT whole square. Okay, now if I will ask you energy between two times, this is very important. So what is the energy between two times? So if I am going to write EL, energy between T2 minus EL of T1. So energy between two time, what you will calculate? First energy means second energy minus first energy. So you will write here half L, this is IL at T2 whole square minus half L, this is IL at T1 whole square. Don't write here half L I2 minus I1 square. Sometimes student will write like this. What? This is half L. This is IL at T2 minus IL at T1 whole square. Okay, this is wrong. This is wrong. This is wrong. So this is totally different meaning. So if you want to calculate energy between 2 points, so second energy minus first energy, like this you have to calculate. This is the important point. Okay, this is the important point. Now the important point, sir, how inductor will charge and how inductor will discharge. How inductor will charge and how inductor will discharge. So here charging equation and discharging equation you should know about the inductor. So one important thing here, if inductor is connected, if inductor is connected by practical source, this is very important point, practical source. If inductor is connected by practical source, the practical source can be practical voltage source or practical current source. So now suppose if we have one inductor like this, and now suppose if this inductor is connected with an practical source, and this is a DC. Which kind of source? DC source. Which kind of source? DC source. So now if this inductor is connected with, suppose this is voltage Vs and this is RS, like this. If this is connected with a practical voltage source, or if this inductor is connected with a practical current source, so practical current source is this Is and this is Vs, and sorry, this is RS and this inductor is L. So in this case two conditions can be possible. Inductor can be charged, inductor can be discharged. This will be depending on the switch position. So now the important thing is, remember my word, this is very important, and most of the student will be trapped here. So if a inductor is connected by a practical source, which kind of source? DC, or you can say constant. It can be unit step or it can be a constant source. So what will be behavior of inductor? So just I am going to remove this thing. So what is the behavior of inductor? Inductor can be charging or inductor can be discharging. Inductor can be charging and inductor can be discharging. So here I am going to draw. So if inductor is charging, okay. So if inductor is charging, so one thing you should remember here, current equation. So first you have to write for inductor always current equation. So what is the inductor current? ILT. You can consider this is the VLT. So what is a inductor current here? This is ILT, and this voltage you can say this is VLT. What is the inductor current? For the charging case, if inductor is charging, so what will happen here? So if inductor is charging here, so this is inductor current, this is ILT. Suppose here two cases can be again present. Initially inductor having some value or initially inductor having zero value. So I am going to assume if initially inductor having zero value, if inductor having zero value, then this is going to be charge like this. Right. So this kind of waveform you will get. And this time will be standard 5 tau time. This is 5 tau time. And you should remember for inductive circuit, tau is nothing but L by R. What is the tau? What is tau? L equivalent by R equivalent or R equivalent by L equivalent. Tell me, what is the tau for RL circuit? What is the tau for RL circuit? You know very well. What is the tau for RL circuit? Sometimes student can write L by R, R by L. Tell me. And what is also for RC circuit? Tell me. Tell me. Time constant for RL circuit and RC circuit. What is time constant for RL circuit and RC circuit? It's a very basic thing, L by R. Okay, sometime you can also use if many number of resistors are present. So L equivalent by R equivalent. Sometime you can also use L by R equivalent if single inductor. Sometime you can also use L equivalent by R. Okay, we will discuss. Don't worry about this. Okay, so just right now you should remember for RC circuit R equivalent into C equivalent. Okay, but for RL circuit, RC circuit, and what is for RC circuit? For RC circuit, you should remember what is tau for RC circuit. This is nothing but R into C, or you can write R equivalent into C equivalent. Okay, or you can write R equivalent into C. So there are so many conditions can be possible. R equivalent into C or R into C equivalent. Okay, so these two things right now you should remember. Okay, you know very well, I hope. So some important point I am going to discuss. If inductor is a charging case, if inductor is charging, so this can be a initially inductor having 0 ampere or 0 current. So this will start from 0. Now my question, this is a continuous function or discontinuous function? This is a continuous function. This is a continuous function. And if this is a continuous function, so what you can say here, in this case, IL0 minus is equal to IL0 plus. So what will be the IL0 minus and IL0 plus? Both having the same value because this is a continuous function. And if IL0 minus is equal to IL0 plus, so energy 0 minus is equal to energy 0 plus. What is 0 here? So we are assuming here t is equal to 0 is switching time. T is equal to 0 is switching time. Switching time. Sometimes switching time can be different. If suppose switching time is T1, so ILT1 minus is equal to ILT1 plus. Similarly, ELT1 minus is equal to ELT1 plus, and T is equal to T1. So this 0 is not a T is equal to 0. This T is equal to 0 means this is a switching time. This is a switching time. When switch is going to be closed and inductor is going to be charged. Are you getting my point? So here suppose one switch was present and at T is equal to 0, this switch is going to be closed. So at T is equal to 0, when switch is going to be closed, so by this supply, this inductor will going to be charged, and after 5 tau second, this will be fully charged. This will be fully charged. So what you can say, this value is here IL0, and this value is IL infinite. IL infinite. Clear this point? So now, what will be this equation? So what will be this mathematical equation of ILT? So what is ILT? So what is the ILT here? ILT will be nothing but so how you can write this transient equation? So transient equation I can write IL infinite plus IL0 minus of IL infinite e raised to power minus t by tau. This is standard transient equation, and this answer is valid for t greater than or is equal to 0. This is for any RL circuit. Any RL circuit. It can be charging, it can be discharging, it can be normal charging or standard charging. So here this is IL infinite, IL0 is 0, IL0 is 0. So what will be this equation? So here this ILT, if this is a 0, so what will be this IL infinite minus of IL infinite e raised to power minus t by tau. And what is tau? L by R. And you can also write IL infinite, okay, 1 minus e raised to power minus t by tau. And this answer is valid for t greater than or is equal to 0. Now the important thing is here. What you will write this 0. Generally you will consider this 0 minus is equal to 0 plus. Okay, but you will always write 0 plus. Always you have to consider here 0 plus. Okay, later I will discuss what is the reason behind this. Okay, so for this equation, IL infinite 1 minus e raised to power minus t by tau. And what is the tau here? Tau is nothing but L by R. L by R. You know this thing? Some important point I am going to discuss. Just wait for that. So this is a first equation can be possible. This is a first equation can be possible when inductor is connected with practical voltage source. Okay, so this you are getting when inductor is inductor is connected with a practical voltage source. Okay, practical and independent. Dependent it cannot be possible here. Practical DC voltage source. Practical DC, not voltage, it can be current also. Practical DC source. Then you will get this kind of equation. Now second condition can also be possible. Second condition can also be possible. Initially, this is your inductor current ILT, and this is your T. This is your T. Now initially inductor having some value, and now this is going to be charged like this, and this will be fully charged at 5 tau second. This is 0. Now this value is IL0, and this value is your IL infinite. This value is IL infinite. Which equation you will get? Same equation, but here IL0 is having some value. Same equation. So for this, what you will get? Again, ILT is equal to IL infinite plus IL. Always you have to write this 0 plus minus of IL infinite e raised to power minus T by tau, and this answer is valid for T greater than or is equal to 0. Now my question, sir, in both the cases, what will be the voltage across inductor? Sir, what will be the voltage across inductor? So VLT. What is voltage across inductor? Is LdI by dt. So differentiation of this and differentiation of this. So from here to here this is constant. From here to here this is constant. Constant differentiation is 0. So what you will get? What you will get? So here you will get 0. Here you will get 0. Okay. Now after 5 tau. After 5 tau, again this is constant. Again this is constant. So after 5 tau, again you will get 0. Okay. Again you will get 0. So before 0 and after 5 tau, and this condition is called steady state. So once you should remember, before switching time and after 5 tau second after the switching time, this both the time is called steady state. I hope you know very well this thing. I hope you know very well this thing. Okay, you know very well this thing. Now the important thing is, sir, what will be the VLT differentiation? So here slope is positive. Here this slope is equal to positive. Positive slope increasing. Yes, again here slope is positive. Here slope is equal to positive. So this is positive slope. So this is positive slope. Yes, sir. Now, and if you will differentiate this equation, what you will get? So here IL infinite is greater than IL0 plus. In both the case, here IL infinite is greater than IL0. Can I write? And here also this IL infinite is greater than IL0. So if IL infinite is greater than IL0, then what will happen? So this value is greater than more, means this answer is negative, and when you will differentiate, so once minus you will get minus minus plus. So you will get positive value. So you will get some constant into voltage e raised to power minus T by tau. So you will get this kind of expression. You will get this kind of expression like this. You will get this kind of expression. This differentiation is 0. Okay. This minus this is positive value. Sorry, this minus this is negative value. Here this minus this is negative value. Yes, sir. So if this is negative value, suppose I am going to assume this is minus 1. Suppose minus 1. And when you are going to differentiate e raised to power minus T by tau, so minus minus will be plus. So you will get function some constant e raised to power minus T by tau. So just I am going to write this k e raised to power minus T by tau. Can I write? So at T is equal to 0, this is a discontinuous function. This is the important thing. This is the important thing. This is a discontinuous function. This is a discontinuous function. You know very well, I know this thing. So voltage across inductor you cannot say, sir, VL0 plus is not is equal to VL0 minus. This is important thing. What is 0 is switching time. So at switching time, voltage across inductor 0 minus and 0 plus is different, but across the current 0 minus and 0 plus current is same. Current is same. Now my question, what is a behavior of inductor and what is a behavior of inductor at steady state? What is the behavior of inductor at steady state? So at steady state, inductor voltage is always 0. So at steady state, inductor voltage is always 0. And if voltage is 0, means short circuited. So inductor behavior at steady state. So what I can say, inductor behavior at steady state, you know very well, is equal to short circuited. Why short circuited? Because inductor voltage is always 0 at steady state. Now one important point I want to discuss here. This was your first equation. Now the second equation. Now the second equation for discharging case. For discharging case. So for discharging case. So now I am going to discuss if inductor is discharging. This is important. If inductor is discharging. If inductor is discharging, then how you can draw the current? How you can draw the current? Suppose initially inductor having some value and this is going to be discharged, and suppose this is 5 tau. So this value is IL0 and here this is IL infinite. Here this is IL infinite and this is 0. And again this is continuous or discontinuous. So inductor current is always continuous. This is continuous. But here slope is positive or negative. Slope is negative. So I can say here IL infinite is less than IL0. Can I write? Yes, less than. So this is the first case. Second case, this can also be possible. This case also be possible. Initial inductor having some value. Now this is not going to be fully discharged. So this is not going to be fully discharged. One you can say that is a normal discharging, and one you can say standard discharging. Standard discharging. So here this value is IL0. This value is 5 tau second. This is 0. I can say this is IL infinite. Can I write? Yes. So again this is a continuous function, and IL infinite is less than IL0. Can I write? So if IL infinite is less than this value, means this difference is positive. So differentiation of this negative e raised to power minus t by tau. Negative. So what voltage you will get? So if you will draw voltage across inductor, so if you will draw VLT, voltage across inductor, for discharging case, what you will get? So this differentiation is 0. So here this is 0, but you will get negative value. And this will goes to discharge like this. This is a 5 tau. And this value you can write minus k. You can write minus k e raised to power minus t by tau. This is the function. So voltage you are getting here discontinuity at switching time. So one thing you remember, VL voltage across inductor 0 minus and 0 plus is different, but current is always continuous. Current is continuous, previously continuous. Always you can write IL 0 minus is equal to IL 0 plus. So for inductor you remember this thing. I hope you know very well. And second thing you remember, inductor energy 0 minus is equal to inductor energy 0 plus. This thing you should know. But inductor voltage VL0 minus is not is equal to VL0 plus. Okay, this thing you should know. These three equations. But remember one important point. All these three conditions are valid for this one. When inductor is connected with your practical DC supply. Now the important thing, sir, at steady state. So this point is, you can say steady state. This is your steady state. This is your steady state. This is your steady state. Sir, this is your steady state. This is your steady state. So at steady state, current is always constant. Sir, this is your either charging case or discharging case. This is steady state. Sir, this is steady state. This is steady state. So at steady state, you can see current is constant and voltage is 0. Current is constant. So here current is constant, here current is constant, here constant, here this is 0, 0, constant, but voltage is 0. So now the important point, what is the behavior of inductor at steady state? Here I have written inductor behavior at steady state is short circuit. Now I am going to change something. At steady state, behavior of inductor, voltage will always be 0. So at steady state, so VL, inductor voltage at steady state is 0 volt. 0 volt. Now inductor current at steady state, IL, inductor current at steady state. So there are two possible conditions. If this is discharging case, so here this is 0. Okay. Sir, here this is constant. Okay. If this is charging case, Here this is constant, here this is constant, not 0. Okay, but here this is constant, here this is 0, here this is constant, here this is 0. So two condition of current can be possible. So current value can be constant, constant or 0, constant or 0. So at steady state, inductor current can be constant, means having some current value, or 0, or 0. If suppose this is a constant, so constant differentiation will be, voltage will be 100% 0. But if this is 0, so 0 differentiation will be again 0. Now the important point is, if inductor current is constant and voltage is 0, what you will assume? Short circuited. But if current is 0 and voltage is 0, then what you will assume? Now you have two choices, either open circuited or short circuited. So now what I can say, if at steady state inductor having 0 ampere current, so you have two choices. You have two choices, inductor can be short circuited or open circuited, anything you can do. Anything you can do, but in all the conditions this is always valid. So what generally what you will assume at steady state, inductor is short circuited, but I am going to change some definition here. Okay, how you remember and how you can apply, because in GATE exam already they have asked one question. Okay, and now I am telling you how you can remember, this. So you can see here, two cases can be possible. VL, inductor voltage steady state, is always 0 volt, always. But in inductor current at steady state, here two condition can be possible. This can be constant. Constant means inductor having some current, means this is a charge inductor. It means this is a charge inductor. Charge inductor. So if this is a charge inductor, so voltage is 0 and current having some constant. What your assumption? Inductor is a short circuited. Inductor is a short circuited. Now the second case, inductor voltage at steady state always 0 volt. Yes. Now inductor current steady state. Suppose if this is a 0 ampere, so 0 ampere differentiation will be, but current is also 0. So here can I say this is the uncharged inductor. If current is 0, this is uncharged inductor. Can I say uncharged inductor? So uncharged inductor, here you can treat here two choices. So inductor can be short circuited or inductor can be open circuited. So here both answer can be correct. So in GATE exam, what you will assume? Sometime at a steady state inductor is uncharged. Sometime you will get this kind of question. So how you remember? You remember like this: at steady state, inductor is charged or uncharged. Inductor is charged if this is charged or if this is uncharged. Easily you can check. So if this is a charged inductor always you can treat by short circuited. But uncharged inductor, you have both choices, either short or open. So you can consider open circuited. So if possible, you can remember like this, but not possible, you can always do short circuit. This is your choice. Here both choices can be possible, but you can go with open circuit, because in previous year GATE exam one question has been asked, and in that question many students are trapped. So just I have proof here key at steady state inductor is short circuited, but if inductor is uncharged, means current will be always also 0. So if current is also 0, so it can also be open circuited. Now come to the important point. So this condition is valid when inductor is connected with a practical DC supply. Now my second question. So these two things should be clear. Okay, you can remember charge inductor short circuited, uncharged inductor open circuited. So this value I am going to write here. Inductor current at 0 minus is equal to inductor current at 0 plus inductor voltage 0 minus is not is equal to inductor current at 0 plus, and inductor energy 0 minus is equal to inductor energy at 0 plus. 0 is a switching time. Here t is equal to 0 is just switching time. This is a switching time. So if switching time is 0, your standard equation of inductor current is ILT is nothing but your IL infinite plus IL 0, always you have to write 0 plus minus of IL infinite e raised to power minus t by tau, and this answer is valid for switching, for greater than or is equal to switching time. This 0 is not 0, this is switching time, and all this thing is valid when inductor is connected, when inductor is connected with a practical DC source, practical DC source. Now I am going to change the topic. If inductor is connected with ideal DC source, then what will happen? If inductor is connected with ideal DC source, then what will happen? This is the important point. This is very, very important point. Okay, inductor allows sudden. Okay, come to the point. So now, if inductor is connected with ideal DC source, two cases can be possible. Yes. The first case is if inductor is connected with ideal voltage source. This is L. Okay, you can write this is voltage is VLT and this current is ILT. Okay, similarly, second question. If inductor is connected with ideal current source, I can say this is IS, this is inductor L, here voltage is VLT and here current is ILT. Then what will happen? This is very, very important point. This is the most important point. Many things you know very well. This equation you know very well. You can put the value, and tau you know very well. Tau is nothing but L by R. Okay, everything you should know. Everything you should know. Okay, now come to the point. When inductor is connected with ideal voltage source, it means when voltage across inductor is constant. The reverse question is here voltage across inductor is constant. Voltage across inductor is constant. Inductor is a constant. Then what will happen? And here current across inductor is a constant. Then what will happen? So here, what is your VLT? Sir, VLT is always Vs. Yes, sir. Sir, if voltage is constant, then what is ILT? Then sir, ILT is nothing but I can write 1 by L integration minus infinite to t VLT dt. So VLT is constant. So constant you can consider common. Sir, what is ILT? ILT is nothing but this is Vs by L, and integration from minus infinite to t, this is dt, and integration of this is nothing but t. So what I can write? This is Vs by L into t. So here current when time is going to increases, this is nothing but, so here can I write inductor current, you are getting some constant into t. Can I write? Yes sir, we can write. So here voltage is constant and current is a linear function. This is called linear charging case. So this case is called, we can say this is a linear charging of inductor. So you can imagine this in two way. First way is sir, if voltage across inductor is constant or current across inductor is a function of time, or in two way you can like this, you can remember, if inductor is connected with a constant voltage source, or if inductor is connected with a ideal DC voltage source, then what is a waveform of this? So just I am going to draw this waveform. So here you can write, sir, what is VLT? So voltage across inductor is constant. Suppose I can say switching time is t is equal to 0. So at t is equal to 0, this is going to be connected. Suppose if switching time is here like this is t is equal to 0, then what will be happened? Initially voltage was 0, suddenly at t is equal to 0, this voltage is constant, so voltage is a discontinuous function, okay, and this voltage is Vs. So again you are getting VL0 minus is not is equal to VL0 plus. Sir, VL0 minus is not is equal to VL0 plus, because you are getting here discontinuity. So again this condition is satisfied. Now the second thing. Sir, what is the inductor current? Sir, what is here ILT? So inductor current I can assume initially 0, and this is going to be linear charging. This is going to be linear because this is a function of t. So here no transient. Always this is going to be charge. So what is tau? This will not be a stable. So here tau is infinite. This is a continuous or discontinuous? Sir, continuous. This is a continuous function. Again, this is a continuous function. But tau is infinite. This is called linear charging. And again here, sir, IL0 minus is equal to IL0 plus. So two cases you should remember. This was the first case when inductor is connected with a practical DC voltage source and inductor is connected with a ideal DC voltage source. So ideal DC voltage source, you will get linear charging, tau will be infinite. Here tau will be L by R, or here you will get exponential function. Clear this point? Now, but in both the case, VL0 minus is equal to VL0 plus will not be applicable. This is not equal, and IL0 minus is equal to IL0 plus. So I hope what is linear charging. So sometime you will get this kind of question when constant voltage is connected with inductor. So slightly remember, sir, this is linear charging. So when ideal voltage source or constant voltage source, or in reverse way you can say when inductor voltage is a constant value, any manner you can remember. Either you can remember when ideal voltage source is connected across inductor, or you can remember when a ramp signal of current is connected across inductor, or you can remember inductor voltage is constant. So you will get this kind of waveform. So again here inductor voltage is a discontinuous function, but inductor current is a continuous function. Now the important point, second diagram. I hope this thing is clear to all of you, and this thing is also clear to all of you. So now I am removing this part. Now come to the second case when inductor current is constant. So here ILT is equal to IS. This is constant. So sir, what is VLT? So what is voltage across inductor? This is IS, constant. And what is VLT? L di by dt. This is L di by dt. So differentiation of this is 0. But when this switch is going to be close at t is equal to 0. So can I write this is IS into UT? Can I write? Because switch is going to be close at t is equal to 0. Or you can write this IS, and this answer is valid for t greater than r is equal to 0. So from here, what ILT? So ILT you are getting ISUT. Can I write? So what will be the voltage across inductor? So what is the voltage across inductor? L di by dt, this differentiation. So L into IS and UT differentiation is del t. This is the important point. So here if I will plot voltage across inductor in second case. So in second case, if I am going to plot voltage across inductor, so what is the voltage across inductor? Is impulse function. So here this is 0, but here you are getting impulse function. So when this is switching, you are getting here impulse function. This is del t. Constant you can write. So K del t I can write. This is del t impulse function. So voltage across inductor is the impulse function. And what is the current across inductor? So current across inductor is here. This is your ILT. So current across inductor is initially this was 0. At t is equal to 0, this is going to be constant, and this value is IS. Again, this is a discontinuous function. So voltage across inductor is a impulse function. This is an impulse function and this is a discontinuous function. This continuous function. This is the important thing. And here, if this is a discontinuous, so IL0 minus is not equal to IL0 plus. So inductor current 0 minus and 0 plus is not same. If inductor is connected with a constant current source, if inductor is connected with constant current source, or if inductor is connected with the impulse voltage source, this you can also replace like this. If this is a voltage source and if this is a delta. So if inductor voltage is impulse or if inductor current is constant. So in this case, IL0 minus is not is equal to IL0 plus. In this case, your current across inductor is a discontinuous function. This is very important concept. So what you remember for DC transient, in DC transient equation you can apply always. Transient equation, this is standard transient equation you can apply, but one thing you remember, the supply across inductor is a practical voltage or current source or ideal current or voltage source. So if ideal voltage source or ideal current source across the inductor, it can be any value. It can be DC, it can be impulse, it can be DC, it can be impulse. Then you cannot apply this formula. And two cases I have considered: when inductor is connected with ideal voltage source or ramp current, this is called a linear charging case. Here IL0 minus equal to IL0 plus will be applicable, but if inductor is either connected with impulse voltage source or constant current source, then in this case IL0 minus will not be applicable to IL0 plus. I hope this thing is remembered to you. The important point is inductor is connected with practical supply or inductor is connected with ideal supply. If inductor is connected with ideal supply, don't go with this formula. Then apply basic concepts. If any value you know, if ideal voltage source is connected across inductor, it means either voltage is given or current is given. So by Ohm's law, V is equal to L di by dt or I is equal to 1 by L integration of V dt. By using this formula, another value you can easily find out. I hope this thing is clear to all of you. So where you can apply this formula, this the important thing. Inductor is connected with a practical DC source. If inductor is connected with ideal DC source, it can be current, it can be voltage or it can be current, and this cannot be DC, this can be DC, this can be impulse function, this can be a ramp function. Don't apply this formula. Clear this point? This is very important point. I am going to discuss some problem from this. I hope this thing is clear. Many times student confuse and every time generally student apply this formula. So the important point is where you can apply this formula. You can apply this formula when supply is a DC or constant. The first thing is important. Second thing is important, if supply is DC or constant, then you can see the supply is DC or constant, then this is a ideal or practical. This is a ideal or practical. This is the important thing. Means circuit having resistance or not. Now the important thing, in this situation, if current is constant, then what is a time constant? So always here current is the steady state at t is equal to 0. So here time constant is 0. So in this case time constant is 0. So total 3 cases is possible. Time constant can be 0, time constant can be infinite, and time constant can be tau. All the 3 cases I have considered here. So tell me if anybody had any doubt in this. Okay. Now later I will discuss some good problem and good level of concept from the transient, so that in GATE exam you will not be wrong. Some important concept I will discuss from here. Okay, and I will discuss some good level of question. I hope this 3 thing is clear to you. When you can use this transient equation, when time constant will be possible. When inductor is connected with a practical supply, and when you can use this equation when your supply is a DC or constant. Okay, but if not DC are constant, if constant but and DC, but if not, this is not practical ideal, then you can apply the basic concept. Clear? So three cases can be possible here. So where IL 0 minus 0 plus you can use, where you cannot use. So only one condition, IL 0 minus and IL 0 plus will not be applicable. When inductor is connected with either constant current source or impulse voltage. Either this current is constant or the voltage across inductor is impulse. So if voltage across inductor is impulse or if current across inductor is constant, then in this case IL0 minus and IL0 plus is different. Okay, so I hope this thing is clear to all of you. So once just confirm me, then after break we will continue the session. Okay, then after break the session will be very important. So just share the link, and after break I will discuss very important part in the transient. One important thing also you remember, charge inductor is short circuited and uncharged inductor have two choices, either short circuited or open circuited. If you are doing short, you have to write current is also zero. So my recommendation for uncharged inductor, you should go with open circuit, or you can draw the short circuited, but you have to write their current is equal to 0. So if uncharged inductor at steady state you are doing short circuited, so you have to assume as a open circuited. So if you are assuming short circuit, so write down the current is also is equal to 0. In question I will apply this thing, so wait for that. So first I will discuss some important concept where students are going to be trapped. Okay, so I hope this thing is clear to you. Now the time is 6:12. Okay, so after 30 minutes we will meet. Okay, so after 30 minutes, so we will meet. Okay, so after 30, okay, so after 30 minutes we will be back. Okay, so we will be back at 6:45. Okay, so 6:45. Okay, so at 6:45 we will meet, and next session will be very important. Next session will be very important. Okay, hello everyone, just confirm करिए एक बार. Hello everyone, so just confirm me audio and video, everything is perfect. Okay everyone, just confirm me audio, video, everything is perfect. Okay everyone, just confirm me audio, video, everything is perfect so that we can continue the session. Okay, so I hope this thing definitely should be clear to you. I hope this thing should be definitely clear to you. When inductor is connected across a practical voltage source or practical current source or ideal voltage source or ideal current source. So these basics should be very much clear. What is the inductor behavior? What is the time constant of inductor? This thing should be very much clear to all of you. Okay, similarly, if we can also talk about the capacitor. Okay, same thing. We can also talk about the capacitor, but some more thing I want to discuss here. If we have one RL circuit, if we have one RL circuit for first order circuit, okay, if we have first order circuit, okay, so right now I am considering first order RL network. So if we have first order RL network, once confirm me audio, video, everything is clear or not. Okay, so if we have first order RL circuit, okay, and here the important thing is here practical source are connected, practical source, and the source is constant source. Constant source means either in terms of UT or in terms of you can say DC. Okay, so in this case directly current across inductor formula I can apply. This is nothing but IL infinite plus IL 0 minus of IL infinite e raised to power minus t by tau, and this answer is valid for t greater than or equal to 0. Here important point I want to tell you, sir, what can be this IL0? Sir, if this is a practical source and constant DC source or constant unit step if you are applying, so it can be in this situation this IL0 minus is equal to IL0 plus is equal to IL0. So anything you can write here, now. Sir, if I want to calculate voltage, so directly this transient equation voltage across inductor you can also apply. You can also write the voltage across inductor equation directly. This is nothing but VL infinite plus this is VL0 minus of VL infinite e raised to power minus t by tau, and this answer is valid for t greater than or equal to 0. Yes, the important thing is here at t is equal to 0, sir, voltage across inductor is a discontinuous function. Yes, so here this is valid for t is equal to 0 plus. So here this is the important point. So directly voltage across inductor you can also find out, but VL0 plus you have to find out. VL0 minus and VL0 plus will be different, but here IL0 minus is equal to IL0 is equal to IL0, but that's why generally we use this equation, because here calculation of this value is important. But the important thing is here, what is VL infinite at steady state always. So here the important thing is, sir, VL infinite is always 0. So VL infinite you don't have to calculate. Yes, but the second important thing is VL0 minus is not is equal to VL0 plus. This is the important point. So either for any RL circuit, either you can use this equation or you can use this equation. But the important thing is here IL0 easily you can calculate. IL infinity you have to calculate. But in this equation VL0 plus you have to calculate. But VL infinite is always 0. So any equation you can use. So my suggestion, if across any RL network, if examiner are interested in inductor current, you can go with this formula. If examiner are interested in inductor voltage, directly you can go with this formula. This will save your time. but the important thing should be clear. Here this value 0 minus 0 plus is same, but here VL0 minus and VL0 plus is different. So sir, what I have to written here, this is VL0 plus. Now the second important point, sir, VL infinite will be always 0. So this will be 0, this will be 0, VL0 plus a raised to power minus t by tau. This will be the answer. This will be the answer. And here one important thing, this is not is equal to 0. So this is greater than t is greater than r is equal to 0, or you can write t is greater than r is equal to 0 plus 0 plus. So this equation is exactly valid for greater than 0 plus or greater than r is equal to 0 plus. Near about both are same. Okay, so either you can use this formula or you can use this formula. Sir, now the question where we don't have to use this formula. If this is second order, first thing, if the second order RL network, you cannot use this formula. Second, sir, if ideal voltage source or ideal current source are connected across inductor, then you cannot use this formula. So in general, transient topic is very easier. In 2 point generally students are wrong. Where this formula is not applicable, student apply, and only in that situation student are wrong. Otherwise this transient topic is very easier topic. I hope this all the concept from this resistive RL network is clear to you. RL network is clear to all of you. If anybody have any doubt in your mind, just ask me. If anybody have any doubt in your mind, just ask me. If anybody have any doubt in your mind, just ask me. Now your question, sir, if suppose for example this our source is not constant, and if this is a second order, if this is a second order RC network, then what we have to do? And now your second question, sir, is there any limitation of this equation? Yes, now I am providing you one question, one problem I am going to provide you. Now suppose for example here one DC voltage and one resistance is given, and now here one inductor is given like this. Sometime this resistance is connected here and switch is given here. Anywhere switch I can connect like this. Suppose this kind of network is given and the switch is going to close at t is equal to 0. Now this value is R, this value is L. Now here, sir, can I use this formula? And here you have to calculate this current is ILT, and here this voltage across inductor is VLT. So now most important thing, sir, these two are transient equation. So this transient equation, where you have to apply? First thing, first order network, RL network. Yes sir, your supply should be practical. It means resistance should be present in the network. Yes sir, resistance are present in the network. Second, sir, our supply is constant, DC or unit step. Yes sir, this is constant. Now most important thing is this formula is valid only when RLC, but we are considering here RL network. So the most important thing is here RL should be constant. So here R and L is constant. This is very important thing. Now my question, if this R is not a constant, if this R is a function of RT, then can you use this formula? No. So here the important point, transient equation cannot be used. Transient equation can't be used. This question has been asked in previous year GATE exam. So you should know the limitation of transient equation. So this basic limitation you remember. Now this is the next limitation. R and L should be constant. So this is a solution of this is practically, what is this? This equation is practically solution of this is a solution of first order linear constant coefficient. This is first order linear constant coefficient differential equation. Solution of first order linear constant coefficient differential equation. So what is the first order constant coefficient differential equation? Dy by dx plus py is equal to q. and here P and Q are constant. Here P and Q are constant. This P will be a RLC and Q is your supply. So here P is nothing but your either R or L or C, and this Q is here your supply. So supply is also constant, and P means RLC in also constant. So if supply is not constant and RLC are not constant, so directly this equation you cannot write. So many students are wrong in this question. What they will do, directly they will apply transient equation. So you cannot apply here transient equation. So sir, how you can solve? By differential equation. By differential equation, you can solve this. So sir, which kind of differential equation we will get here? Which kind of differential equation we will get here? So this is first order RL circuit. This is a first order RL circuit. So first order, okay. So first order, but here this is linear. Yes, this is linear. RT, it will depend on the RT. RT is a linear function or non-linear function, but this is not a constant coefficient. So here this is first order RL circuit. This is linear circuit, linear, but this is not a constant coefficient. So this is linear, not a constant coefficient, not a constant coefficient. This is the important thing. So you cannot apply this direct formula. So I hope this thing is clear. So in GATE exam, all the question easily we can solve by this equation, but where we cannot apply. So generally student, now we can find out in these two situations we cannot apply. So IITians have asked this question. Now the important thing is, remember, supply should be constant, circuit having resistor, and RLC value should be independent of time. RLC should be also constant. So where you can apply directly this equation. Now what is the inductor current equation? Here what is IL, and here what is the inductor voltage equation, and what is here VL? This is 0 plus. This is the important point. Only this thing you should remember. Any transient question we can handle. So now how we can solve? So just I am going to remove this part. Okay. So from where you get this? This is a first order linear constant coefficient differential equation, solution of that. Now, so sir, how you can solve? You can write the equation KVL V is equal to, this is RT into, just I am going to assume here current is IT. This RT into this is IT plus this is L DIT by DT, and IT is nothing but inductor current. You can also write this is IL. Can I write? Now you have to solve this differential equation. This differential equation, this is DILT by DT plus here this is not a constant, this is RT by L into ILT is equal to, this is V by L. This differential equation you have to solve. So now this differential equation you have to solve. In mathematics definitely you have to study. So the important thing is, sir, this point is not a constant. This is a not a constant. That's why directly this equation you cannot apply. So solution of this differential equation will be ILT. This is your homework. How we can solve this differential equation. If you are not comfortable in differential equation, you can also go with Laplace transform. But here don't go with Laplace transform. So my recommendation, how to solve when this R, L and C are not a constant value. So you can go with a differential equation always. This is a previous year GATE question. Just I have written here a standard circuit, but exact question you can find out. Okay, and you can try. Just I have given the concepts. Okay, so this only this differential, this is very basic first order linear, but this is not a constant coefficient. In mathematics you study this. Okay, so just you have to solve this differential equation. I hope this thing is clear to all of you. Now the second important point, one more important point I want to discuss here. For this transient equation. So where you cannot use and what is where you can use this transient equation. Okay, now the second important point, this equation is valid when switching time is t is equal to 0. So here this equation is valid when switching time is t is equal to 0. But sir, if switching time is different, or if in any circuit more than one switching time is present, so one can be only 0, second can be different. So now if switching time is if switching time is t is not is equal to or t is equal to t1 or more than one switch in the network in that situation, what will be the function? So just I am going to assume if at t is equal to t1 is the switching time, is your switching time, then what will be this modified equation? So in that situation, what is the inductor current? So inductor current you can use ILT is equal to, this is IL infinite final current, okay, plus this IL0 represent switching time current. So now you can write, sir, this is nothing but IL, this switching time is T1. This is IL T1. Now minus of IL infinite. And now here e raised to power minus t by tau. This will be also modified. This will be minus of t minus of t1 divided by tau. This is important point. And this is equation is valid for t is greater than or is equal to switching time. Switching time is t1. This is the important point. So where we have modified equation here, here and here. This 3.0 is replaced by t1. This 3.0 is replaced by t1. 0 is replaced by t1. In this point, 0 is replaced by t1. 0 is replaced by t1. In this point, 0 is replaced by t1. This is very, very important point. Now, then sir, what will be the voltage across inductor? So voltage across inductor will be VL infinite. So VL infinite will be always 0 plus this, sir, VL T1 plus. So VL, after just switching, you have to find out the voltage across inductor minus of VL infinite. VL infinite is 0, but for remembering both equations, I am going to write here e raised to power minus of t minus t1 divided by tau, and this answer is valid for t greater than or is equal to t1 plus. This answer is valid for t is greater than or is equal to switching time. So T1 is switching time. So only you should remember this. So I hope in RL circuit all the point is clear to you. In RL circuit all the point is clear to you. Okay. Now sir, if I hope this thing is clear to you now. So this equation is again modified. So where you can use this equation, where you cannot use this equation, this is the important point. Okay. So all the first order RL circuit. So two cases can be possible in the RL circuit. First case, this RL and C and voltage. Suppose RL, C and voltage is not a constant. So you can write the differential equation and you can handle. We have one more approach, Laplace transform. So Laplace transform approach where we can use. So in second order network you can use, or if your supply is not constant. So if supply is suppose exponential e raised to power minus alpha t like this, or you can say not constant. If supply is suppose exponential not constant or any another in another or second order network. So if supply is not constant or second order network, then you can go with Laplace transform. Then Laplace transform can be used. Laplace transform can be used. This is the important point. Then Laplace transform can be used. In this situation, we can use Laplace transform. In this case, we can use a Laplace transform. Okay, so you should know how we can write inductor in Laplace domain and capacitor in Laplace domain. So how you can write inductor in Laplace domain? If this is inductor voltage is VLT, inductor current is ILT, and suppose this is inductor, and suppose initial current, if this is I0, suppose inductor initial current is I0. So what is this Laplace domain? Everybody should know inductor is replaced by one series voltage source, but this is minus and plus. This value will be Ls, this value will be VL of S, this current is IL of S, and this value is Li0, L into I0. Sir, what is I0? This is a 0 minus or 0 plus. So across inductor 0 minus current is equal to 0 plus, but you remember this I minus. But across the inductor IL 0 minus is equal to every time IL 0 plus, sometime when inductor voltage is impulse function or inductor current is constant. So that's why this thing should be remembered. You should write I0, but this is exactly I0 minus, I0 minus. So in Laplace domain, you can replace inductor in this way. Clear this point? So if you are getting second order network, or if you are getting your supply is not a constant, in that situation you can go with Laplace transform. So if suppose if in this question your supply is e raised to power suppose minus of t, so in this situation here in place of v you will get e raised to power minus t. So it is better you can go with Laplace domain. So we have two choices, either differential equation or Laplace domain. You have to think which will be easier for me. So if you are comfortable in Laplace, you can go with Laplace. If you are comfortable in differential equation, you can go with differential equation. Okay, so inductor, I have discussed all the important point for inductor. Now I am coming with capacitor. Okay, so many thing will be repeated. So in fast way, just I am going to tell you. Okay, so now I am going with capacitor. So if anybody have any doubt in this, just ask me. If anybody have any doubt in this, just ask me. If anybody have any doubt. So this is very important point, very basic important point. Sir, what is this T1? If switching time is different, then you can use here switching time. So this is practically switching time. Sir, can I use transient equation for inductor voltage? Yes, we can use, but here this will be plus. This is a VL. Switching time at a plus position, not at minus. And inductor current, you can, if IL0 minus and IL0 plus is different, then you can add 0 plus, because this equation is not valid for 0 minus. This equation is valid for greater than 0. Okay, but here sometime student will write, sir, this is IL0 plus. No, this is not I0 plus. IL0 minus is equal to IL0 plus in most of the cases. So you can write I0 minus 0 plus, but if I0 minus and I0 plus is different, in that situation you cannot write this I0 plus. This is practically I0 minus. Okay, so these 2 points should be clear. Sir, what is exactly this IL0 plus, or at time T1 plus, and this is, sir, I0 minus. This 2 point is very important. So here you should also remember, if resistor, capacitor, inductor are not a constant, then this transient equation is not valid. So validity of this transient equation is very important. Very important. Okay, very important. So now I am moving towards a capacitor. Now I am moving towards capacitor. Then I will discuss some good question. Okay, so now I am going to start capacitor. Now I am going to start capacitor. Okay, so capacitor basic formula you should know in voltage, capacitance and charge. So one basic formula, sir, Q is equal to C into V. So this will be many time required. And second, sir, suppose if we have one capacitor, this is capacitor. Sir, if we have one capacitor, so voltage across capacitor is VCT, current across capacitor is ICT. So again you should remember this is plus minus and direction of current is same. So what is our assumption? Capacitor is a passive element, and always you write current is entering from positive terminal, and this value is C. So what you can write, Vc of t is equal to 1 upon C integration from minus infinite to t. This is ICT dt. This is voltage across capacitor, and current across capacitor is the C dVct by dt. So same equation you will get for inductor and capacitor, only here voltage in inductor current, where current, here voltage. So I am not going with again charging and discharging, everything is same. So here what the important point, so here capacitor voltage 0 minus is equal to Vc 0 plus. Okay, when this will be applicable, capacitor is connected with practical supply, but capacitor current 0 minus is not is equal to capacitor current at 0 plus, because capacitor current is always a discontinuous function. In one cases Vc0 minus is not equal to Vc0 plus, when you can say when capacitor is connected with constant voltage source. So if capacitor is connected with constant voltage source, which ideal constant voltage source, then Vc0 minus is not equal to Vc0 plus. So this concept only you have to apply, when your circuit is connected with a practical supply, practical DC supply. So here I can say, I can write energy across capacitor 0 minus is equal to energy across capacitor 0 plus. Limitation should be, remember, same as it is with respect to inductor, which we have studied in inductor. Same limitation and condition you have to apply here. So this basic thing you should know. Now at steady state. So at steady state, what is the behavior of capacitor? So this formula is differentiation. So at steady state in capacitor current, so capacitor current at steady state is always 0 ampere. This thing you should remember, and 0 ampere is always open circuited. Always open circuited. So at steady state, capacitor is always open circuited, but capacitor voltage at steady state, two cases can be possible. First case is this can be a constant. So capacitor voltage at steady state is either constant or 0. So constant means this is the charge, capacitor, and 0 means this is a uncharged capacitor, If charged capacitor, so what we can write, charge capacitor, it means constant differentiation 0, 0 differentiation 0, yes. But if voltage is 0, we can say short circuited. But if voltage is constant but current is 0, you can say open circuited. So here you have two choices. So at steady state, what you can write about capacitor? So at steady state, capacitor you can write either this is a charge, either this is a uncharged. So what you can write, charged capacitor is always open circuited, but uncharged capacitor, you have two choices, open circuited or short circuited. If you are going to assume open circuited, you have to write there, sir, voltage is also 0, but my recommendation, if possible, you can treat as a open circuited. But after your some time you are getting your gate exam, so you don't have to change your concept, but remember this thing, So if you are getting at a steady state, capacitor is fully uncharged, so you can do short circuited, you can do open circuited, but you can write there voltage is also 0, This is the important point. Sometime otherwise sometime you can get wrong. 99% question will be asked from this part. This is open circuited. Okay, so uncharged capacitor, my recommendation, you can use short circuited, not open circuited. So charged capacitor you can use open circuited, and uncharged capacitor you can use short circuited. Similarly, inductor, charged inductor will flow some current, so that will be short circuited. Uncharged inductor having current 0 ampere, so you can capacitor. Transient equation for capacitor, so capacitor voltage and capacitor current, both transient equation you can write. Here graph I am not going to draw. So here you can see transient equation for RC circuit, for first order RC circuit, where R is present, and here R and C are constant. This is the important point. And the supply is a constant RDC. Then only you can write transient equation. So voltage across capacitor is nothing but Vc infinite plus Vc0 minus of Vc infinite e raised to power minus t by tau, and this is valid for t greater than or is equal to 0. Now here Vc0 is equal to Vc0 minus is equal to Vc0 plus, and tau is equal to, this is R equivalent into C equivalent. Okay, now similarly, sir, can we write capacitor current? Yeah, you can also write capacitor current directly. So ICT is nothing but IC infinite plus IC, now this is 0 plus, this is important point, IC 0 plus minus of IC infinite e raised to power minus t pi tau, and this answer is valid for t is greater than or equal to 0 plus. Because at t is equal to 0, capacitor current is a discontinuous function. Here IC infinite, sir, IC infinite is always 0. And what is IC 0 plus? Sir, IC 0 plus is not is equal to IC 0 minus. This is important. So either you can use this formula or you can use this formula. Suppose switching time, this both are when switching time is t is equal to 0. When switching time is the t is equal to 0. Now if switching time is not t is equal to 0, if switching time is not t is equal to 0, then what you can write? If switching time is not t is equal to 0, so you can write, suppose switching time is t1, this is t1, this is t minus t1 divided by tau, and this is greater than t1. So this will be the equation. And what will be this equation? Sir, this is t1 plus, and here this is t minus of t1 divided by tau, and this is valid for t1 plus. So sometime later I will use this equation, so wait for that. So this is a transient equation, and where you cannot use transient equation, if R and C are not constant and supply is not constant or DC. So sir, in this situation what you will do? Go with Laplace transform or go with differential equation. So capacitor in Laplace domain. Capacitor in Laplace domain. So how you can write capacitor in Laplace domain? So we have this capacitor, and suppose this voltage is VCT, and if here current is ICT, and here initial voltage is V0. Initial voltage is V0. So what is this Laplace domain? So in Laplace domain, capacitor is represented by one series voltage source, but this is plus minus. Remember, inductor is minus plus, this is plus minus. Now this value is 1 by CS. This is your voltage across capacitor VCS. This is current across capacitor ICS. This is plus minus. Now this value is V0 by S. I hope you know very well this thing. The important point is this is plus minus, here S is also present, but in inductor S is not present, and that is minus plus, and the value of that voltage source is Li0. Sir, what is here V0? So V0 is here, you can consider generally V0 means Vc0 minus Vc0 plus is same, so you can write anything, but what is exactly this? This is exactly Vc0 minus. This is exactly Vc0 minus. This is exactly Vc0 minus, but you can write anything because Vc0 minus equal to Vc0 plus equal to Vc0. So you will not get any confusion. So this 0 minus 0 0 plus is very important point. So this is for the capacitor. This is for the capacitor. So I hope now inductor and capacitor, everything definitely should be clear to you. Okay, so now I am going to take some questions from these concepts. Now I am going to take some question from this RL circuit and RC circuit. I hope this thing is clear to all of you. Okay, now one more important point I want to discuss here. One more important thing I want to discuss here. Suppose if examiner will ask you differentiation of this value, suppose differentiation of this value at 0 plus. So one thing you should remember, sir, what is inductor VLT? VLT is nothing but L dilt by dt. So if examiner are interested in, sir, dil 0 plus by dt, so what will be this value? So this one L you can write here 1 by L, and this is nothing but VL 0 plus, you can write this. So if examiner are interested in first differentiation of inductor current at 0 plus, so VL 0 plus, by comparing VL 0 plus you can find out this value. Similarly, second value, if examiner are interested in capacitor current ICT, so ICT you can write this is C dVCT by dt, and if you want this value dVC 0 plus by dt, so this value you can write 1 upon C, this is IC 0 plus. You should remember this two value. You should remember this two value. Okay, so now I am going to consider one good problem from this part. So now I am going to start some question from transient. So transient equation, if switching time is different, T1, how you can write? In Laplace domain, LNC, how you can write? Okay, transient equation limitation should be very much clear. What is a linear charging case? When you will get linear charging case, when capacitor, you can say inductor voltage is impulse, similarly capacitor current is impulse. If I will ask you, when you will get a capacitor current across capacitor is impulse, suppose if I will ask you, suppose, so if this is a capacitor, so if this is capacitor and if the voltage is here constant, suppose this is Vs, so what will be this capacitor current? What will be this capacitor current? So here, and you can say, sir, here one switch is going to be closed at t is equal to 0. So can I write what is the voltage across capacitor? This is nothing but Vs into ut. Can I write? Or Vs for t greater than 0. So you can write Vs into ut. So what is capacitor current? This is C dVc by dt. So here you will get a capacitor current impulse, impulsive capacitor current. So here this is C into Vs and differentiation of ut is del t. So you are getting, I can write this is constant into del t, del t. So this is capacitor current. So when you will get a impulsive capacitor current, so when capacitor voltage is constant, when you will get a impulsive voltage across inductor, when inductor current is a constant, and in this situation Vc0 minus is not is equal to Vc0 plus. This is the important point. So if somebody will ask you, when Vc0 minus is not is equal to Vc0 plus, you can say when capacitor current is a del t function or impulsive function, in that situation Vc0 minus is not is equal to, this is not is equal to Vc0 plus. So I hope this thing should be very much clear. So everything will depend, the inductor and capacitor are connected with practical sources or not. So practical sources or not, this is the important thing. And now the second important thing is, what is the source? Source is DC constant or not DC or constant. Third important thing, RLC are constant or not. You have to concentrate on this thing. If yes, you can directly apply transient equation. Okay, now come to the point. Now come to the point. First question, just note down. So first problem, just you can note down. And I am going to take very good problem from previous year. One good problem. I hope this thing is clear to all of you. I hope this thing is clear to all of you. Okay, sir, will there be digital crash course? Yeah, I am planning and 100% digital crash course you will get. Okay, so just note down one problem. Okay, and this is a very big problem, very tough problem, not a tough problem. And in GATE exam, generally a student feel, sir, this question cannot be solved within 3 minutes. If you have studied my this lecture, within 2 minutes you can handle the question. So now you can see here. Now you can see here one circuit I am going to draw. One circuit I am going to draw. Here one resistor. Here one resistor. Here one switch. Here one switch is given, and here one resistor and one inductor. This is one current source. One current source is given. Okay, now here one capacitor is given. One capacitor is given like this. Again here one resistor and one current source. One current source, and again here one resistor is given like this. One resistor is given in this way and like this. This is the circuit. And second current source is downward. This is downward. This is downward. So now I am going to write the value 1. This is 1 ohm. Okay, this is, sir, 1/2 ohm. This current is 1 ampere. Sir, this is 1 farad. This is 1 ohm. This is 1 ohm. This is 1 ohm. This is 1 ohm. Sir, this is 1 ohm, and this is 1 ampere. Okay. Again, I am going to recheck the value. All the value is 1, 1, 1, 1, 1. Only one resistance is 0.5 ohm. Okay, now here this is one switch, and here this is second switch. This is two switches. This is two switches. Okay, and now the position is, this is P1 position, this is Q1, and this is P2, and this is Q2. So this point is P1, P2, and Q1. Q2 and P2. P1, Q1, and P2, Q2. And this is switch, and this switch is S1, and this switch is S2. So here two switches is given. Okay, I hope definitely you have definitely seen this question, and if you have not seen this question before, that is good, that is good, that is good, that is good. So here voltage across capacitor is given, this voltage is given, this is capacitor voltage VCT, this thing is given. Now I am writing the question. The circuit shown in the figure is used to charge the capacitor alternatively from two sources. So capacitor is going to charge from this source, then this source, this source, this source, this source, this source simultaneously. They have mentioned the switches S1 and S2 are mechanically coupled. So they are mechanically coupled. So now they have mentioned here two conditions. Two conditions for first condition they are given for T is from 2 n T, this is 2 n T, to this is 2 n plus 1 into T. Okay, so from 2 n T to 2 n plus 1 into T, and here n is equal to 0, 1, 2, 3 and so on. N is integer, positive integer. Here the switch position is in this first switch, in this position S1 is connected to P1 and S2 is connected to P2. So in this situation, so for you can put the value up here 0. So T2 0 to T switch S1 is connected to P1 and switch S2 is connected to P2. So both switch are, you can say, a right side. Now the second condition, here I am going to write second condition. Second condition for 2n plus 1 into T, 2 this is less than or is equal to, you can write less than or is equal to. Okay, they have not mentioned less than or is equal to because two conditions, this is less than or is equal to and this is only less than, Now 2n plus 1 T, 2, this is less than 2n plus 2, this is 2n plus 2 into T, and again n is equal to 0, 1, 2, 3 and so on. So in this case S1 is connected to Q1 and S2 is connected to Q2. This thing is given, So simply you can see this first case you can write here, I can write so when this switch is connected, so you can write that this is 0 to this is T. From 0 to T, switch is connected to both the switch here and here. Now here if this is n is equal to 0, T to 2T, so this is T to 2T. So T to 2T, this condition. Then again here if n is equal to 1, so this is 2T to 3T. Then again here 3T to 4T. This is going to be happen. It means from 0 to T, both switch is connected here. From T to 2T, both switch is connected here. From 2T to 3T, again both the switch is connected here. So every T switch is moving. So from 0 to T second, both the switch is connected here. Then T to 2T, both the switch is connected here. Then 2T to 3T, both the switch is connected here. So every T switch position is going to be changed. This thing is given. So I hope this thing is clear to you. Now what they are asking, assume that the capacitor having initially charged. So they have mentioned initially capacitor is uncharged. So VC0 is 0 volt. So initially capacitor is uncharged. So initially VC0 minus is 0 volt. This is given. Okay. So initially capacitor is uncharged. So now they are asking what is a capacitor voltage VCT. So what is VCT? What is VCT is equal to question mark. This you have to find out. So VCT you have to find out. So in this situation you can write, you can see, can I plot one graph here? Yes sir. And can I divide it into many parts? Okay, this is 0, this is T, this is 2T, this is 3T, this is 4T, like this. One more I can consider, this is 5T. So from initially everything is 0. Okay, so VCT is 0 and current is also 0, everything is 0. Now from 0 to T, so from 0 to T, this switch is connected here and this switch is connected here. This switch is connected here and this switch is connected here from 0 to T. Okay. So now you can see this is open circuited, and this 1 ampere current is flowing across this capacitor. Now the important thing, I am going to draw this circuit for 0 to t, for 0 to t. What is the circuit? This is capacitor, here one resistor, and here this is current source. Here this is current source, and this VCT you have to find out. Now this is 1 ohm, sorry, this is 1 by 2 ohm, and this is 1 ampere. Now important thing is here, current source having series resistance. There are no any use of current source. There are no any use of this resistance if resistance are connected in series with current source. If I will ask you what will be the current here, sir, what will be the current here? So here current is 1 ampere. So this is a standard normal charging case. No. Here current across capacitor is constant. So here current across capacitor is constant means ICT is equal to 1 ampere. All this thing is valid for 0 to t. So here ICT is 1 ampere. So this is constant current. So this is a constant current across capacitor. So current is constant. How much? 1 ampere. So sir, what will be the VCT? So sir, capacitor voltage is nothing but 1 upon C integration of this is valid for 0 to t, and here this current is ICT dt. So from 0 to t, what is VCT? So VCT is nothing but 1 by C. C is given, this is 1 farad. C is given 1 farad. So 1 by 1 integration. ICT is also 1 ampere. So this is 1 ampere into t. So this is t. So from 0 to t, the capacitor voltage is, this is linear charging case. This is linear charging case. So here two plot I am going to draw. One is for current and one is for voltage. One is for, first I am going to write, sir, what is capacitor current? And second I am going to plot here, what is capacitor voltage? Capacitor voltage you have to find out. But first I am going to write capacitor current, because capacitor current from 0 to t. So this 1 ampere current will flow across it. Directly you can write, sir, from 0 to t, what is a current across capacitor? So from 0 to t, sir, this is 1 ampere. From 0 to 1, and at t is equal to 0, switch position. So switch, at a switching position, this current is definitely discontinuous. So here this is going to be changed. So from 0 to t, this is 1 ampere. This is 1 ampere. Now the second circuit, when this is connected from here to here, and this is connected from here to here, this is second condition. In this condition, this is open circuited, and now always you have to consider this is ICT. Why? Already I have tell you, always current across capacitor is incoming from the positive terminal. So this 1 ampere current will flow here. So this is 1 ampere. So from second case means in this case. So in this first case, capacitor current is 1 ampere, and in this case capacitor current is minus 1 ampere. So every time capacitor current is 1 ampere, minus 1, 1, minus 1, 1, minus 1, 1, minus 1 is going to be happened. There are no any use of this. There are no any use of this, because if resistor are connected in series with current, so there are no any use. There are no any use. So what is going to be happen? From 0 to t 1 ampere, from 2 to t minus 1 ampere, then again 1 ampere, then again minus 1 ampere. So this is the current waveform. This is minus 1 ampere, this is 1 ampere. Sir, this is minus 1 ampere, this is 1 ampere. Sir, then what will be the voltage? This is 0. Here this is t, here this is 2t, here this is 3t, here this is 4t, and here this is 5t. Sir, then what will be the voltage? This is linear charging case. So here you can find out, sir, what is the VCT? So here, sir, what is a VCT? So VCT can I write C dV by dt. Sorry, VCT is 1 upon C, integration of ICT dt, and 1 upon C is 1. So integration of ICT. So you can write here integration of minus 1 into t, sorry, plus 1 into t. So this is t, and here VCT is equal to minus of t. Can I write? You are getting minus of t in between this situation. So t slope minus t, t minus t. In another word, what is VCT? So VCT I can also write 1 upon C means 1, integration of ICT dt. Can I write? So integration of this function. So this is a step. So if you have studied signal and system, I hope definitely you have studied. So just you can integrate this. So what is the integration of this? So from 0 to this, 0 to you are getting ramp function, and here amplitude is plus 1. So here slope is plus 1. Slope is plus 1. So if this duration is t, so this height will be t. So this will be t, because slope will be 1. This is, remember, If here amplitude is 1, then here slope will be 1. Now, from t to 2t, here amplitude is -1, then slope will be -1. This slope will be -1. Here slope will be +1. Here slope will be -1. So, if this is t and if this distance is t, so this will reach to 0. Again, from 2t to 3t, you will get +1 slope, then -1, then +1, then -1. So, this is t, this is t. This is the answer. So, what is VCT? VCT, you are getting a triangular function, and inductor current, you are getting a square wave. Both sides symmetrical square wave. So, now examiner can ask you anything here. This question is basically come from signal and system plus network analysis mix. Now, VCT mathematically you can easily write. So, examiner have provided here 4 mathematical equation. So, now from that 4 mathematical equation, you have to check which mathematical equation will represent this one. Easily, from 4 options, easily you can write. So, examiner can either provide you this graphical VCT or graphical ICT, or examiner can also provide you here mathematical expression for this. So, easily you can handle this question within 1 minute, 2 minutes, or within 3 minutes, anybody can handle. So, here easily you can see in the first 0 to t, this 1 ampere current is flowing, positive 1 ampere, and this remaining t, this is -1. So, +1, -1, +1, -1 in every t duration, this is going to be happen. So, if ICT you can plot, easily VCT you can plot. So, graphically you can play. Don't write mathematical equation. So, don't write this, don't write this. Directly, first you can plot here this ICT, then ICT, VCT 1 upon C, 1 upon C, 1 by 1. Integration of, for 0 to t duration, this is ICT dt, means integration of ICT is nothing but VCT. So, integration of this square wave is you are getting a triangular wave. You are getting a triangular wave. And what is the magnitude of this triangular wave? This is the important thing. This is t. This is t. So, like this, you can handle this category of question. Like this, you can handle this category of question. Like this, you can handle this category of question. So, everyone, I hope this problem definitely is clear to all of you. This is a case of linear charging. Linear charging of capacitor. Examiner, can you ask the question? Examiner, can you ask any category of question from transient? From transients. Examiner can ask you any category of question from transients. Please, everyone, just confirm me if you have any doubt in this question. If anybody have any doubt in this question, just tell me. Please reply, everyone. Everyone, please reply. Do you have any doubt in this question? Okay, now I am moving towards next question. Okay, now I hope basic question easily you can handle. Okay, now now next question I am going to take. Suppose, for example, okay, once confirm me this thing is clear or not. Okay, one good question I am going to ask you, one very good question. Now the second problem. Now the second problem. Okay, many times students are stuck in this problem, but this is a very basic question. This is very basic question. This was a very basic question. Okay, now the second question. Now the next question. Now the next question. Now the next question. Okay, now here just note down the next question. Here one current source is given. One current source is given in this way. Okay, one current source is given in this way. One capacitor and one resistor are connected here like this. Okay, and here one switch is given. One switch is given. Okay, now here also one more switch is given. Here also one more switch is given. So two switches is given. One switch, this switch is going to close at t is equal to 0, and here this switch is this is going to be closed and this is going to be open at t is equal to 0. So this switch is going to be open at t is equal to 0, and they have provided voltage across this current source is Vs. Voltage across voltage across this current source is Vs, and now this resistor is 100 ohm, and now voltage across this capacitor is also given in this plus minus direction, and this is Vc. This thing is given. This thing is given. Okay, now a combination of, here the question is, I am going to read out, a combination of 1 microfarad capacitor, 1 microfarad. So this capacitor is 1 microfarad. Okay, and Vc0 minus is also given here. Initial voltage across capacitor is given, that is minus of 2 volt. This is minus of 2 volt. This thing is given. This is given. So here this thing is given. So initial voltage across capacitor is also given. And now the question is, okay, connected to a 20 milliampere current source. This current source value is 20 milliampere. This current source value is 20 milliampere. This thing is also given. Now examiner asking, what is a voltage across capacitor for few seconds? So for few seconds of t greater than or is equal to 0, Vs is equal to. So you have to find out what will be the Vs just after the switching. For plot they have provided here. So just I am going to write here 4 options, and this is again a very good problem. Again this is a very good problem. Okay, and this is again a previous year question. Okay, so here Vs plot they have provided. So option A, first Vs, this is Vs. Okay, second option B, again this is Vs. One more option. So first option is given, this is going to start from -2. This is going to start from -2. And in second option, this is going to again start from -2. But graph, this is not a linear, this is exponential. Now in option C, again this is Vs. Now in option C, this is going to start from 0. All this is t, this is t, this is t, this is t. This is third option. And fourth option they have provided, option D they have provided, again this is going to start from 0. This is Vs. This is Vs. So first you have to find out, sir, Vs will be linear charging, all are charging. So Vs will be linear charging or exponentially. And what is a value at t is equal to 0? What is the value at t is equal to 0? What is the value at t is equal to 0? Again this is very good problem. This is very good from anybody can think directly. And anybody can tell me which will be the answer. I am waiting. Just tell me. Think and tell me. Think and tell me. Just I am waiting. Anybody can tell me. Okay, one answer A. Okay, let's see. They are asking Vs. The important thing is they are not asking Vc. They are asking Vs. So Vc0 minus is -2 volt. So now you can see here at t is equal to initially voltage, you know, initially voltage this is given -2 volt. So voltage across this capacitor initially this is the -2 volt. Okay, now at t is equal to 0, what is going to be happen? At t is equal to 0, this switch is going to be closed, this switch is going to be closed, okay, and this switch is going to be open. So if I am going to draw the network at t is greater than or is equal to 0, what is going to be happen? Sir, this is current source and this current source is 20 milliampere, okay, 20 milliampere, and here voltage is Vs. Now capacitor, is, you can write this is capacitor, all time I am going to write for all time, and this is your resistor, and this switch is closed, this switch is closed. Now if I will ask you what is a current across capacitor, can sudden change? Yes sir, sudden change. So capacitor current is 20 milliampere. So if I will draw here this capacitor current ICT, so this is your VC, this is VC. So you can draw here IC and VC. If you can find out VC, easily you can find out this VS, and this is R is your 100 ohm. I can write this is R, I can write this is C, and what is the value of C? C is given 1 microfarad. So first, if I will draw capacitor current, sir, what is capacitor current? So initially we don't know what was the capacitor current. I can assume this was open circuited, this can be anything, but initially if I am going to assume this was 0, at t is equal to 0, this is going to be sudden change. So you know very well capacitor current can be discontinuous. Yeah, and capacitor current you are getting ICT suddenly 20 milliampere. This is 20 milliampere. Can I write? Yes, ICT will be 20 milliampere. So sudden change. So if capacitor current is sudden change, so current source and series resistance. So what is this circuit? This is a capacitor is connected with ideal source. This is the question from ideal source. Can I write? Yes sir, because current source having series resistance no any value. So here this is current across capacitor is constant. So if a current across capacitor is a constant, then what will be the voltage across capacitor? Initially voltage they have given. Initially voltage across capacitor, that is minus 2 volt. So VCT was initially, this was minus 2 volt. Okay. Sir, this was initially minus 2. But after t is equal to 0, what is going to be happen? So you know very well, VCT voltage across capacitor is nothing but 1 upon C integration of ICT dt. Can I write? Yes sir, we can write. So we can write 1 upon C. C you can write 1 microfarad. So 1 upon 1 micro you can write. Integration of a current, and this current is constant, and constant integration is ramp function. So this is nothing but linear charging case. So what you will get here? 1 upon C. ICT is constant. So just I am going to write ICT. This is ICT is constant. So just I am going to write this is 20 milliampere. So what you will get here? Can I write 20 milli divided by 1 micro? Can I write 20 milli by 1 micro, and integration of a constant? So you can write this integration. And if you are going to write 0 to 2 dt, can I write plus? This was initial. And what was 0? VC 0 minus. So VC 0 minus was given minus 2. And this is VC 0 minus. Can I write this integration from 0 to t? And ICT is constant. So now what is VCT? So VCT you are getting from here. This VC 0 minus is minus 2 plus 20 by 1 micro. Milli and micro will be cancelled out. So you will get 20 into 1000. 20 into micro will be up 20,000. So minus 2 plus 20,000 t. Will you get integration of dt is t. So minus 2 plus 20,000 t. Y is equal to mx plus c. So VCT you are getting this one. So what VCT you will get this one. But examiner are asking VS. This is the important point. They have asked VS, this is VS and this is VS. So can you apply here KVL? Yes, we can apply here KVL. So if you will write here KVL, so VS will be is equal to this is nothing but VCT, this is VC plus 100 into 20 milliampere, 100 into 20 milliampere. So 100 into 20 milliampere will be VCT plus 100 into 20 milliampere. So this is a 20 into 1000, 2000 into milli means plus 2. So Vs you are getting VCT plus 2. So VCT value you can put. So what is Vs? Vs is equal to minus of 2 plus 20,000 T plus 2. So this plus 2 and minus 2 will be cancelled. So what is Vs? This is 20,000 T. So both answer you have find it out, Vs and VCT. What is Vs? 20,000 T. So Vs is a linear function that is going to start from 0. That is going to start from 0 and the slope will be 20,000. The slope will be 20,000. They are not mentioned here slope. So what will be the answer? Option C. Option C. Now if examiner will ask what is VCT? So this is Vs. VCT will start from minus 2 and the slope will be plus 20,000. If this slope is plus 20,000, so this answer is not Vs, this is VCT. So if in this question examiner will ask you what is a capacitor voltage, so this will be the answer. If examiner is asking what is Vs, then this will be the answer. This will be the answer. So this is a case of linear charging. This is the case of linear charging. This is exponential charging. This is exponential charging. I hope this problem is clear to you. This is basic but very good problem. This is a previous year gate problem, and this question, okay, this question has been asked gate 2014. Okay, I hope this problem is clear to all of you. I hope this problem is clear to all of you. Okay, so just I have considered linear charging cases. So I hope now this linear charging cases easily you can handle. Okay, now the next question I am going to discuss. Next question I am going to discuss. Next question I am going to discuss. I am not going to discuss basic problem. I am going to discuss where generally you are getting wrong in GATE exam. Okay, that point basically I am going to discuss. So good level of question. Okay. Only you should remember where transient equation used. So in both the question, two question I have discussed here. In both the question, we have not used transient equation. We have not used a transient equation. Now, many time in GATE exam, question will be asked from the capacitor, two capacitor. Okay, many times. So just I am going to take one question from two capacitor. So note down the next problem. Next question, just note down. Next question from two capacitor. I am going to ask you. So, sorry. This is one voltage source of 3 volt. Here one switch is given and one capacitor here. Here one more switch and here one more capacitor. So here two capacitor and one voltage source. Voltage source 3 volt. Capacitor, this is the C1. This is 1 farad. This is sorry. Sorry, na. This is 2 farad. And two switches given. One is S1 and one is S2. So at t is equal to 0, this is going to be open. At t is equal to 0, and at t is equal to 0, this is going to be closed. So initially this switch was closed. At t is equal to 0, this is going to be open and this is going to be closed. Okay, now here in the figures on all the elements are ideal, both are ideal. So here resistance is 0 and the switch position is given. Okay, now if the voltage VC2 across the capacitor C2 at t is, so here they have mentioned voltage across C2 at 0 minus is equal to 0 volt. So initially this capacitor was uncharged. This will be charged because the switch was connected. And now they are asking at t is equal to 0 plus. So at t is equal to 0 plus. At t is equal to 0 plus. Okay, the voltage across the capacitor combination. So at t is equal to 0 plus. VC1 0 plus and VC2 0 plus. Both will be same. At t is equal to 0 plus, both will be same, and this will be is equal to question mark. Both will be same and this will be question mark. 4 options I am going to provide you. You have to give me the answer. 1 volt, 2 volt, 1.5 volt and 3 volt. 1 volt. Second option is 2 volt. Third option is 1.5 volt. And last option is 3 volt. This kind of question many times they will ask in GATE exam. But I will discuss some important thing also here. They are asking voltage. I will ask you energy. Many things I will discuss in the question. So how you can handle this question? Once you can see in all this circuit, resistance is absent. It means no transient equation. So here transient equation you cannot use. If resistor is not present, so you can assume resistor is 0. So what is time constant? Time constants are R equivalent into C equivalent. No resistors means time constant is 0. So here no transient. So capacitor will be charged instantaneously. So what you can say, if I will draw T is equal to 0 minus. So what will be the circuit T is equal to 0 minus, or you can say T less than 0. So switch S1 was closed. So what you can write, sir, this was 3 volt and this switch was closed. So this capacitor. So at steady state capacitor will be fully charged. Yes, sir. So charge capacitor is open circuit. So you can write VC10 minus. So what is VC10 minus? This is equal to 3 volt. So now here VC0 minus is here. This VC10 minus is 3 volt. And here VC20 minus is equal to 0 volt. So initial voltage you know. So here initial voltage you know. Now at T greater than or is equal to 0. So when this switch is going to be open and this switch is going to be closed, how much time will be required? My first question, how much time will be required to charge this capacitor? So for T greater than 0, this is the first capacitor, switch is going to be closed, this is second capacitor. So this capacitor will transfer some charge from this C1 to C2. So this was C1 and C1 is 1 farad. This is C2, this is 2 farad. 2 farad. And here initially voltage I can write, this is V1. So V1 is 3 volt. Here I can write initially voltage, this is 0 volt. So what is going to be happen when you will close the switch? So this is called equilibrium case. So when two capacitors are connected back to back, so one capacitor is going to charge to second one. So this is called equilibrium case. Equilibrium case. So in equilibrium case, I hope this thing many students studied in 11 and 12 class. Okay, but if you are not studied, no worry. So what is going to be happen? This charge capacitor will charge to the second capacitor. So how you can think about this question? One charge capacitor is connected with uncharged capacitor or low charge capacitor. Suppose if this is 3 volt, this is 0 volt. So current will flow from higher potential to lower potential. So this is 3 volt, this is 0 volt, and if switch is going to be closed and if there are no any resistor between this, so immediate this will charge to this, both the capacitor will charge and both the voltage will be same. So this will be V and this will be V. So can I write at infinite or at 0 plus, how much time it will take? Within 0 plus second both will be charged. So this will be charged at 0 plus second because here no resistor are present. So if I will ask you, the current will flow across here, yes sir, current will flow. So which current will flow? Here impulsive current will flow. So if I will ask you, sir, what is a voltage across this capacitor? At T is equal to 0, what is voltage across this? 3 volt. So if constant voltage is connected across capacitor, what will be the current? So here if I am going to write, suppose this is VC2T. So what is VC2T? If I am going to write, second voltage across second capacitor is a constant. This is 3 volt. This is 3 volt. Initially 3 volt. So if voltage across capacitor is constant, then what will be the current? Then if voltage across capacitor is constant, but for how much time? So for very small time. So just I am removing this part right now. So this is very small time. 3 volt will be connected here. So slightly this will be charged. And then both voltage will be same. Then this will be stopped. So if I will ask you, what is a current function here? So here the current will flow. This is the impulse. So impulsive current will flow here. Impulsive current. So one here in GATE exam, examiner have asked which current will flow from here to here. So you can write impulsive current. Okay, so for how much time current will flow? For 0 second, very small time, but current will flow or not? Yes sir, current will flow. If current will not flow, then this will not be charged. Then this will not be charged. So definitely this will going to be charged when you are going to close the switch. But here time constant is 0 second. Time constant is 0 second. That's why how much time current is flowing for 0 second. So you can say impulsive current. So if examiner will ask you which current will flow here, so you can say impulsive current. So at t is equal to 0, impulsive current will flow. Now, but examiner have not asked in this question impulsive current. They have asked what is the value of this voltage. So how you can handle this question? So what is going to be happen in the circuit? So initially this is charge capacitor, and charge capacitor is connected with, if a uncharged capacitor or low charge capacitor, then charge will be transferred from one place to another place. So here charge will transfer from here to here. So charge will transfer for how much time? The time at which both the voltage is not going to be same. So if this voltage and this voltage will be same, so this is 3 volt is going to down and this 0 volt is going to up. When both the voltage level is same, then flowing up charge or flowing up current will be stopped. But now my question, in whole circuit total charge will be same. Yes sir, same. So what you can say, initially here charge you can find out. Here initially charge, here initially charge, you can find out this is Q2. So initially Q2 is C into V. So here this is 0 coulomb. Initially here Q is equal to C into V. So this is 3 coulomb. So here initially charge is 3 coulomb. Here initially charge is 0 coulomb. I hope this thing is clear. Now at steady state, you can say at steady state. You can say at steady state. So at steady state means t is equal to infinite. Or in this situation, t is equal to 0 plus, because when this circuit will reach to steady state at 0 plus, because there are no any resistance in between C1 and C2. So time constant will be 0. So immediately second capacitor will be charged. So that's why examiner have asked 0 plus. Exactly this is steady state. Exactly this is steady. So examiner will ask you two questions. If resistor are not present, they can say 0 plus, or they can ask you if resistor are present steady state. Both the case are same. So at equilibrium case, they can also ask you this thing, at equilibrium case or at steady state, or if resistor is not present, they can say at t is equal to 0 plus. So how you can handle? You can find out total charge initially. Now at steady state, total charge in the circuit will be same. So now at steady state, what is going to be happen? This capacitor value will be, this is 1 farad, yes sir. This capacitor value will be, sir, this value will be your 2 farad, yes sir, 2 farad. But voltage across this will be same. Here voltage will be same and here voltage will be same. So now if I will ask you, sir, what is here Q1 dash? So new charge will be definitely reduced, and here charge will be definitely increases. So what will be Q dash? 1 into V. So this is 1 into V. This is 1 into V. Sir, what will be here Q2 dash? Q2 dash will be 2 into V. Sir, this is 2 into V. This is 2 into V. So you can write Q is equal to Q1 dash plus Q2 dash. So Q1 dash plus Q2 dash will be equal to here total Q. So here total Q was Q1 plus Q2 is equal to 3 coulomb. 3 coulomb. So initially total charge in the circuit is 3 coulomb. When this switch is going to close, here some charge will transfer from here to here, but in circuit total charge will be same. This is the important point. So Q1 dash plus Q2 dash will be 1V plus 2V, and this value is nothing but 3 coulomb. This is 3, and this you can write, this value is 1V plus 2V. This is 3V is equal to 3. So V is equal to 1 volt. So here answer is at steady state, or you can say at t is equal to 0 plus, voltage across both the capacitor is 1 volt. So what will be the answer? 1 volt is the answer. What will be the answer? 1 volt is the answer. Why you are wrong? Why you are wrong? 1 volt is the answer. 1 volt is the answer. 1 volt is the answer. So here charge is 1 into 1. Here 1 coulomb charge. Here 1 into 2. Here 2 coulomb charge. And voltage across both the capacitor is 1 volt and 1 volt. So how you can handle this category of question? Here examiner will ask you two questions. First question, which kind of current will flow across here, which kind of current will flow across here. So if you can say here resistor is 0, so if resistor is 0, so two cases can be possible, either time constant is infinite or time constant is 0. Either time constant is infinite or time constant is 0. You can see when you are going to connect charged capacitor, uncharged capacitor, immediately second capacitor will be charged if resistor is not present. So current will flow for very small time. So you can say that is a impulsive current will flow. Very small duration, and very small duration you can say that is a impulsive current. You can say impulsive current. You can say impulsive current. Now this question you can also handle by using Laplace transform, but in GATE exam don't go with Laplace transform. Okay, so now the second question. Now here the second question is, sir, what about the energy? What about the energy? Sir, is there any energy loss will be happened or not, and what will be the energy? So now come to the point. Now if I will ask, sir, here energy, initial energy, so here energy E1, I am writing E1 initial before t is equal to 0. Here energy before t is equal to 0, this is E2, this is 0 joule, yes sir, 0 joule. Here energy E1 half CV square, this is half CV square, so here half, this C is 1 farad into voltage is here 3 volt, 3 square, this is 9 by 2, this is 4.5 joule. Can I write? So E1 is 4.5 joule and E2 is 0 joule. So total energy in both the capacitor initially. So total energy is here E is equal to 4.5 joule. So I hope this thing is clear. Now come to the second case. I hope this thing is clear. Now I am removing this part. So for the second case, sir, what will be the energy? What will be the energy? And now my question, is there energy loss or not? Anybody can tell me. Anybody can tell me here energy will be loss or not. So you can see the this case, in this case, sir, E2 dash, this is nothing but half CV square. So here this is half, C is 2 and voltage is a 1. So this is 1 square, 2 and 2 cancel. This is 1 joule. Sir, what will be the energy here? Sir, this is E1 dash. So after equilibrium or at 0 plus or at steady state, so E1 dash half CV square. So here voltage is 1, this is half into, this is 1 into voltage is 1 square. So this is 1 square, 1 into 1 into 1, 1 by 2. Sir, this is 0.5 joule. What is total energy? So here E total after equilibrium 1.5 joule. How much energy you are getting? 1.5 joule. How much energy you are getting? 1.5 joule. And initial energy was half CV square. Here energy was, this is a 4.5 joule. So how much energy is lost? So here energy loss is equal to, here energy loss is equal to 4.5 minus 1.5, this is 3 joule. So examiner can ask you initially energy at steady state, what is the final energy? What is the final energy? Examiner can also ask you the way energy loss. Like this, you can handle this category of question. Okay. So here answer will be 1 volt. Sometime student remember. I hope the energy concept is also clear to you. So here examiner can ask you, what is the at steady state? What is charge across here and here? So here charge will be 1. Here charge you can find out 1 V and V is 1. So here charge is 1 coulomb. So here Q1 dash is 1 coulomb. Here this is Q2 dash at steady state is, this is a 2 into V and V is 1 volt. So this is 2 coulomb. Voltage is here 1 volt. Voltage is here 1 volt. What is energy? Energy is here, this is a 0.5 joule and energy is here 1 joule. So energy, charge and voltage. So first you have to calculate voltage. Sometime student will remember direct formula. Sir, Vc1 infinite and Vc2 infinite is same. And infinite means steady state. So at steady state, you don't write infinite. So at steady state, if two capacitors are connected, then at steady state, both the voltage will be same. Yes, sir, both the voltage will be same. And a student will remember V1 C1 plus V2 C2 divided by C1 plus C2. Sometime student will remember direct formula this. Same thing I have calculated here. V1 C1 means this is nothing but Q1 and this is nothing but Q2 divided by C1 plus C2. And this is, you can say Vc1 is equal to Vc2. So this is nothing but Q1 plus Q2 divided by C1 plus C2. Same thing. Same thing. So don't remember this. In this way, in GATE exam, you have to try to solve. Okay, so sometimes student will remember like this. Okay, so you can put here what is Q1, or you can say what is V1 C1. What is V1? Initially voltage is 3, C1 is 1 plus V2 is 0, C2 is 2 divided by C1 is 1 plus 2. So this is 0, this is 3 by 3. So 3 by 3 is, this is 1 volt. So directly you can write down the answer. Directly you can write down the answer. So when two capacitors are connected back to back, means one charge capacitor is going to uncharge another capacitor. So you can write in this way. You can write in this way. Clear this point? Clear this point? Okay. Now, so here examiner can ask you question from energy also. Here examiner can ask you question from energy also. Examiner can ask you question from the energy also. Clear? Okay. Now, so if you have doubt in this question, just ask me. Can you handle this category of question? Now, if suppose for example, one more question I am going to consider. Next problem. Next problem. Suppose we have one DC voltage. This is V. Okay. Now here one switch is going to be closed, and this switch is going to be closed at t is equal to 0. Here this is one R, and one capacitor is given. This is R and this is C. This is C. This is C. Now, if I will ask you, initially Vc0 minus is equal to 0 volt. So initially capacitor was uncharged. Initially capacitor was uncharged, and here you can write this current is IT. Here you can write this current is IT. Now my question. At steady state, what is a voltage across capacitor? And now my second question. From 0 to steady state, how much energy will be stored by capacitor? So now my question, what is a 40 greater than or is equal to 0, what is the energy by capacitor? What is the energy by resistor? What is energy by resistor? That is dissipated energy. Here this is stored energy and this is delivered energy. What is energy delivered by voltage source? So now my question, when you are going to close the switch, current will flow and capacitor will be charged. So how much energy will be stored here? How much energy will be dissipated here, and how much energy will be delivered by the voltage source? Directly, many students know this answer directly. Many students know the answer of this. Anybody can tell me? Anybody can tell me direct answer? So this is the school level question, but in GATE exam, they will ask. And here some important concept I will discuss. Here some important concepts I will discuss. So here transient equation you can use. Yes sir. Here capacitor is connected with a practical voltage source, and that is the constant voltage. So here transient equation can be used. So first thing, sir, can we use here transient equation? Here transient equation can be used. Okay, but in previous all three question we cannot use transient equation. Why you cannot use transient equation? Because in all the previous three question, practical sources are not connected with capacitor, but here transient equation can be used. So here VCT directly you can write, but examiner are interested in here energy. But if suppose VCT if you want to write, so VCT is nothing but sir, Vc infinite plus Vc0 minus Vc infinite e raised to power minus t by tau. This answer is valid for t greater than 0. What will be the Vc infinite at steady state? So at steady state, you know very well, this is voltage, this is resistor, switch was closed, capacitor is charged, capacitor is open circuited, and this is Vc infinite. So current will be 0. So Vc infinite is equal to V. And what is Vc 0? That is 0 already given. So what is the equation? Sir, Vct is equal to Vc infinite is V, and this is plus, this is 0. V minus, I can write V e raised to power minus t by tau. And what is tau? Is equal to R into C. 1 R and 1 C is given. Can I write? So V minus V e raised to power minus T by RC. Can I write? Tau is nothing but R into C. And this you can also write, this is V 1 minus e raised to power minus T by RC, and this answer is valid for T greater than 0. Now if I will ask you what is ICT? So ICT either you can write C dVCT by dt. So differentiation of this is nothing but this difference is 0, this differentiation is minus and minus plus, this will be plus, this is C and this is V and this is divided by RC. Can I write? Into e raised to power minus T by RC. So you can write here, sir, what is ICT? So ICT is nothing but C by C cancel out. You can write V by R e raised to power minus T by R. See, this answer is valid for T greater than 0. Now your question, sir, can we find out this current by transient equation? Yes, this is important point. So this ICT we can also find out by using transient equation. This is nothing but IC infinite plus this is IC 0 plus, this is important, minus of IC infinite e raised to power minus T by tau. So now IC infinite is 0 because IC infinite is 0 ampere, but IC 0 plus you have to find out. So at T is equal to 0 plus you have to draw the circuit. So at T is equal to 0 plus, we know very well at T is equal to 0 plus, what is circuit behavior? The switch was closed, this was resistor and capacitor, uncharged capacitor at T is equal to 0 plus, or this capacitor is replaced by voltage source. And what is voltage source? Vc 0 minus. This is Vc 0 minus and Vc 0 minus is 0 volt. It means this is short circuited. So this is V and this is R. Here this current is IC 0 plus. So what is IC 0 plus? So IC 0 plus is nothing but V by R. V by R. You can put this value in equation. ICT is equal to IC infinite, that is 0. IC 0 plus is V by R e raised to power minus T by tau, and tau is R into C. And this answer is valid for T greater than 0. Same answer. Both the answer are same. Just here you can use transient equation, either directly current equation or voltage equation. But important thing is here you have to calculate 0 plus value. So circuit should be drawn in 0 plus. Here you have to calculate Vc infinite. So circuit should be drawn in steady state. So there are two different methods. Here circuit will be drawn in steady state, means infinite. Here circuit will be drawn at T is equal to 0 plus. So in which you are comfortable, you can go with. So just we have to find it out the equation. Here equation I am going to write. Okay, so Vc T equation you have find it out. Sir, V minus V e raised to power minus T by RC, like this. Okay, and what is ICT equation? ICT equation we are getting V by R e raised to power minus T by RC. Okay, and both the answer is valid for T greater than or is equal to 0. This answer directly within 10 seconds we can write. Okay, but the concept should be clear. So now you have find it out VCT and ICT. So anything you can calculate. So at T is equal to infinite energy you can write. So now we can find out each and every value. Now can I remove this part? Yes, I am going to remove this part. So just I want to tell you how you can use transient equation. So in this question, and how circuit behavior at 0 plus, how circuit behavior is at T is equal to infinite. I hope you know very well this thing. Okay, so now come to the point. Our question was how much energy. So here energy initially 0 0 0, everything is 0 0 0 at initial. What is the final energy? So can I write what is the energy across capacitor? Half CV square. So steady state minus 0. So can I write energy across capacitor at infinite minus of energy across capacitor at 0. So this is nothing but half C. This is a voltage across capacitor. You can write this is VC at infinite square minus half C voltage across capacitor at 0 square. So voltage across capacitor at 0 is 0. This is 0, and here this is half. This is C, and voltage across at infinite. Already you calculated V. So this is half into this is C into V square. So this is half CV square. Every student know this thing, half CV square. Every student know this thing. Sir, half CV square. In school class you have studied. So energy across capacitor is half CV square. But now the question is how much energy will be delivered by this and how much energy will be absorbed by this. So how you can calculate energy across resistor and energy across voltage. So can I find out energy across this voltage? So energy across this voltage will be how energy you calculate integration of voltage into current. So you have to calculate from 0 to infinite, yes, and voltage into current. So this voltage and current is here, this current is IT dt. Can I write voltage into current? So voltage into current you can write, okay. But here current direction is important. So if you are considering current direction this one, so this is delivering energy, and if current is entering, then this is a absorbing energy. So here we don't have to calculate negative or positive, so just you can put the positive value. But if you will write current direction in this way, so that energy will be absorbed energy. So if current is entering from the negative, so this is delivered energy. So this you can also write here delivered, because this current and voltage direction you have assumed current is entering from the negative terminal. So here just you have to solve this. So this is 0 to infinite, this V is constant, and what is IT? So what is IT means ICT, both the current and ICT current are same. This is V by R e raised to power minus t by RC into dt. So just here to solve this. So this is V square by R, this constant. What is integration of this? E raised to power minus t by RC divided by minus 1 by RC. Can I write an e raised to power minus t by RC, and limit you can put 0 to infinite. Can I write? Yes. Now you can solve this. So what you will get? Sorry, something wrong, na? This is 1 upon like this, okay, and e raised to power minus t by RC, limit will be 0 to infinite. So what you will get? R and R will be cancel out, this R and R will be cancel out. So what you will get? CV square minus of CV square, and what will be the limit? E raised to power minus infinite minus of e raised to power 0. E raised to power minus infinite, 1 upon e raised to power 1 minus 0, and e raised to power 0 is 1. So you are getting minus of CV square. This is 0 minus 1 minus minus plus. So this is CV square. So this energy delivered by this energy is CV square. So this minus this, so this will be half CV square. So you remember direct this answer. If initially this capacitor was uncharged, then how much energy will be stored by this capacitor at steady state? Half CV square. And how much energy will be absorbed by this resistor? Half CV square. How much energy will be delivered by this voltage source? CV square. How much? CV square. CV square. Clear this thing? So now you can also solve energy across this resistor by this. So energy across this resistor, integration of power. So you can 0 to infinite voltage across this resistor, you can write VR, or you can write I square into R. So current square into R. So you can write current square into R dt. If you will solve this, again you will get half CV square. This is your homework. Okay, you can try. You will get half CV square. Now the second question. I hope this thing is clear to all of you. So direct you should remember. So if one RC circuit, if your DC supply are delivering the energy CV square, then the energy will be stored by the capacitor CV square. Okay. Now if I will ask you one problem. If you have one capacitor, and if you have one here supply, this is supply, and this is going to be close at t is equal to 0. Now this is 10 volt, this is 2 farad. So at steady state, so now I will ask you how much energy will be stored by this capacitor, and how much energy will be delivered by this, and how much energy will be lost. So here three things I am asking: energy delivered by 10 volt source, energy stored by 2 farad, and how much energy lost. Energy lost. Here resistor are not given, but energy will be lost or not, this is my question. Anybody can tell me. So direct, if resistor is given or not, energy will be 100% lost. So if current will be transferred, so this is examiner choice. Sometime examiner will not mention resistor, sometime they will mention the resistor, but 100% energy will be lost. So here energy will be CV square, here half CV square, and if examiner will provide you resistor, this absorbed energy, and that is a loss energy half CV square, and this is loss energy is half CV square. So what is CV square? Says 2 farad, V square is 10 square, 100 into 2. So this delivered energy is 200 joule. Here energy stored by this half CV square. So half into 2 cancel. This is 10 square, 100 joule. So here this is 100 joule, and loss energy will be 100 joule. Loss energy will be 100 joule. This is very important concept. This is very important concept. Clear this thing? So this question already has been asked many time in GATE exam. So GATE exam, they are asking the question, when two capacitors are connected, one capacitor is going to be charged to the another capacitor like this. Second category of question like this, from the energy they can ask you the question. So if they will provide you a resistor, or if they will not provide you here resistor, energy will be definitely lost. How much amount of energy will be delivered by this, that is CV square. How much energy will be stored by this half CV square? How much energy will be lost? Half CV square. Now I am going to change the question. Now I am going to change the question. Now here I am going to change the question. Okay. And now I am going to change the question. Now in GATE exam, again you will be trapped. How you will be trapped? Let's see. Now suppose if VC0 minus is equal to 2 volt. Suppose. So initially capacitor voltage is 2 volt. Then what will happen? In this case, just you have to calculate this value. So now I am removing this part. Yes, sir. You can remove this part. So this is the next question. Just note down. This is the next question. This is the next question. Just you can note it down. You can note it down. If capacitor having initially, if capacitor having initial voltage, if capacitor having initial voltage, in this case, what will be the this capacitor voltage? VCT equation. So VCT equation is equal to VC infinite. VC infinite is V. Okay. Now this V I can consider the 10 volt. This I can consider 10 volt. So this is 10 volt. And this capacitor value is 2 volt. I am not representing here resistor. So loss will be definitely happen. Loss will be 100% happen. So if this is 10 volt, if this is 10 volt, and this is nothing but V, this capacitor value you can assume 2 farad. 2 farad you can assume. Okay. Now initially voltage across this capacitor you can assume here V0 is 2 volt. 2 volt. In this case, my question, how much energy will be delivered by this? How much energy will be stored by this, and how much energy will be lost? So energy delivered by 10 volt. So now the first question, energy delivered by 10 volt, energy stored by 2 farad capacitor, and how much energy lost? So now this question will be same or different. This equation will be same or different. What will be the VCT? So VC infinite will be 10 volt plus VC0. This is 2 minus 10 e raised to power minus t by tau. So now minus t by tau. So now you can assume here one resistor. Okay. Now I can assume here one resistor R. So this is t by RC. Can I write? This is t by RC. So what will be this answer? This is 10 minus 8 e raised to power minus t by RC. RC value later I will put. Okay. So 10 minus 8 e raised to power minus t by RC. This answer is valid for t greater than or is equal to 0. Okay. So VC infinite plus VC 0 minus VC infinite e raised to power minus t by tau. Now what is the VCT? I can write here. Sir, this is 10 minus 8 e raised to power minus t by RC. Okay. This answer is valid for t greater than 0. Now, sir, what is ICT? So ICT is nothing but you can write C dVc by dt. In another way, directly ICT you can also find out by transient equation. By transient equation, I am going to find out from here. So what is the, this is C, difference of this is 0, and this differentiation is minus of 8 into minus of 1 upon RC. Can I write? Yes, minus 8 upon minus 1 upon RC into e raised to power, sorry, this is differentiation, not integration. This is differentiation. This is differentiation. Okay. So what you will get, this is C, and this is minus of 8 into minus 1 upon RC e raised to power minus t by RC. You are getting like this. You are getting like this. So this ICT is nothing but C dV by dt. So minus minus plus. So what you will get, C and C cancel out. So 8 by R e raised to power minus t by RC. You will get like this. 8 by R e raised to power minus t by RC. This is ICT. This is ICT. So ICT you have find it out. What is ICT? This is 8 by R e raised to power minus t by RC. And this answer is valid for t greater than or is equal to 0. Okay, now. So what is the energy across this capacitor? So EC infinite minus of EC 0. What you will get? Sorry, infinite minus 0. So at infinite, this is half CV infinite square minus of half C. Can I write VC 0 square? Can I write? So directly energy across capacitor directly you can write. This is half CV square, half into C is 2 farad. So this is 2 farad. VC infinite is 10 volt. So this is 10 square, but minus of this is half into 2 into what is VC 0? 2 square. So this is 2 square. So from here you will get 2 and 2 cancel. This is 100 minus 2 and 2 cancel. This is 4, 96 joule. So how much energy will be stored by this capacitor? This is 96 joule. In previous case that was 100 joule. But now the question, how much energy is transferring by the 10 volt. So if you want to calculate this energy across this 10 volt, so this equation is required. You don't write 96 into 2 in this question. Don't write. Sometime what student will do, here how much energy is stored, double energy will be delivered by this. No, that will be applicable if initial energy is 0. So here two question can be framed. In first question, initially this energy or this voltage is 0, then this is half CV square and this will be delivered CV square, and how much loss? CV square. But that direct formula you can use when this capacitor was initially uncharged. When capacitor was initially uncharged. But if initially capacitor is charged, so definitely this energy will be minus here, and you cannot write directly here CV square. Your answer will be wrong. You have to calculate. In this situation, you don't have direct formula. You have to calculate. So what is energy delivered by 10 volt? So energy delivered by 10 volt will be integration from, you have to find out from 0 to infinite. How much energy delivering from 0 to infinite? How much energy is stored by this capacitor from 0 to infinite is 96 joule. So here voltage is a 10 volt. So this is 10 multiply current. What is the current? Current is 8 by R e raised to power minus t by RC. 8 by R e raised to power minus t by RC into dt. Voltage into current. Can I write? Yes, sir. Now integrate this. So energy delivered by 10 volt voltage source. So this is 80 by R. Okay, this integration is e raised to power minus t by RC, and this limit is 0 to infinite. Divide by minus 1 by RC. So here you can say, that's why R I have not provided. R and R will be cancelled out, but C I have provided. So from here you will get this is minus of 80 into C. This C will be at numerator minus 80 into C, and if you will put this limit e raised to power minus infinite plus e raised to power 0. So e raised to power 0 is the 1. This is minus minus plus. So what you will get? 80 into C, and what is C here? C is 2 farad. So 80 into 2 is equal to 160 joule. So how much energy will be delivered by this 10 volt? This is 160 joule. This is very important point. So value of R is not required if examiner is providing R or not. But you can assume, if examiner will not provide you R, you can assume, because R, value of R is not required here. So now you can use here. So if this is 160 joule and this is 96 joule, so here this is 60 plus 4. So 64 joule is the loss. So this is very important concept. In GATE exam, already this kind of question has been asked. So definitely this question can be again asked in GATE exam. So two category of question can be framed from here. Initially, if capacitor was fully uncharged, so here energy stored by capacitor is half CV square. This will be delivered CV square. How much loss? Half CV square. But if initial here voltage is given, or if initial energy is given, then you have to calculate like this. So capacitor energy directly you can calculate. Already I have tell you in the previous class also. half CV square, half CV2 square minus half CV1 square. So if you want to calculate energy between 2 points, second point energy minus first point energy, you can calculate like this. So this energy easily you can calculate, but here energy or here energy, how you can calculate? One equation is required, one equation is required, one equation is required. So now suppose if you want to calculate energy across this R, suppose if you want to calculate energy across this R, so integration from 0 to infinite, I square into R. Yes, you can put I square into R. So I square into R dt. So now you can put here 0 to infinite. What is I square? So here this square 8 square by R square. So what you will get? 8 square by R square into this R I can write here. This R I can write here. This is square. So e raised to power minus 2t by RC. E raised to power minus 2t by RC. Sometime what student do e raised to power so t square by RC square. Yeah, what you are doing? E raised to power, if this is minus x square is a e raised to power minus 2x. You know this thing very well. So now this is a dt. This is dt. And you have to solve this equation. So here I am going to write. Here I am going to write. Okay, here I am going to write. And from here, what should be your answer? Our answer should be 64 joule. 64 joule. And now the second question, sir, R is required or not? So till now R is not required. So definitely again R is not required. Okay, so now this 1R and 1R will be cancelled out. So here what you will get, ER is equal to energy across this resistor is nothing but 8 square is 64. 64 divided by R. So this is 64 divided by R is constant. Integration of this is e raised to power minus 2t by RC, e raised to power minus 2t by RC divided by minus 2 by RC, and limit is 0 to infinite. Can I write? Now you can write this again. This R and this R will be cancelled out. It means R is not required. It means R is not required. So here you will get minus of 64 into C divided by 2. Can I write? This C will reach to numerator and this is minus 64 by 2 into C. And this limit if you will put, so e raised to power minus infinite minus e raised to power 0. E raised to power 0 is minus 1. So minus and minus will be cancelled out. So this is 64 by 2 into capacitor value is 2. 2 and 2 will be cancelled out, 64 joule. So you are getting the same answer, 64 joule. So sometime if examiner will provide you initially voltage or energy across capacitor, so don't write directly this capacitor will store half energy and this will deliver double energy. No, in this situation everything will be changed. In this situation everything will be changed. In this situation everything will be changed. Okay, so once just confirm me if anybody have any doubt. If anybody have any doubt, tell me. So there are so many good questions I have dealt here. So there are so many good questions. Okay, so some very small thing also I am going to discuss in the transient part, and then we will start AC circuit. So tomorrow already a signal and system is scheduled, so I will change this. So tomorrow one more class I will conduct for the network, and tomorrow mainly I will discuss AC circuit, and all the AC circuits we will finish in one day class. So tomorrow I will discuss AC circuit, and if I will get some 2-3 extra questions from here, I will discuss. But according to me, all the important thing I have discussed in the transient. All the important thing already I have discussed in the transient. But if I will get some good questions, so I will discuss also. Okay, and then I will start AC circuit. Many students are waiting for the AC circuit. Many students are waiting for the AC circuit. Okay, so in comment you can write, are you feeling some confident in transient or not? Okay, and if required, I will take some duration of classes for transient, and then I will start AC circuit. So just tell me what you want exactly. AC circuit or transient, you want more transient or AC circuit can I start? Okay, so tomorrow again one more classes we will conduct for this network theory, and then we will start signal and system marathon. Okay, so please everyone just comment me what you want. Okay, so I will decide some question I will take from transient, and then we will jump to the AC circuit. Okay, So if anybody have any doubt, what I feel, which I have taught you in the revision class, many question directly will be asked from this concept. Okay. Okay. So okay, AC circuit. So if I will get some good problem from transient, I will discuss that, and then AC circuit we will start. Okay, but I have discussed many things in the transients. Most of the important concept, two capacitor question can be asked. This kind of energy question can be asked. Transient equation already we have applied here. So if you can apply in the circuit, in any circuit you can apply. Where you don't have to apply transient equation, that thing should be also remember. One homework I have provided. In this same circuit, if you can assume this, if this R is a function of time, then how you can solve the differential equation. Okay, so tomorrow we will meet. Sir, are you going to take digital marathon? Yes sir, I will take digital marathon, don't worry. Okay, so signal and system, communication and digital, all these three subject marathon I will conduct. Okay, so tomorrow at 4 p.m. we will meet, and already signal and system session is scheduled, but that will be changed. So different subjects, network analysis will be happen tomorrow. Okay, so tomorrow we will meet again. Okay, thank you, take care, bye bye and Jai Hind. If anybody have any doubt, you can post. If anybody have any doubt, just you can post. If anybody have any doubt, you can post. Okay, okay. 4 p.m. Yeah, timing is 4 p.m. Our all the session will be conducted at 4 p.m. because at morning you have different subjects. So at evening 4 p.m. we will conduct. Okay. So no doubt tomorrow 4 p.m. we will meet. Thank you. Take care. Bye bye. Jai Hind once again.